Indian Resins Manufacturer Association, it is my privilege to warmly welcome all of you today's session of technical lectures. We are honored to host such distinguished gathering of industry experts, professionals, researchers, and stakeholders from across the resin and allied sectors. This session reflects Irma's ongoing commitment to fostering knowledge exchange, innovation, and technical advancement. We are confident that the insights shared today will contribute meaningful to the growth, sustainability, and global competitiveness of the Indian resin sector. Thank you everybody for being here, and we look forward to a session full of valuable learning and discussion. One more request, souvenirs are respectfully placed on your places. You all can take that away from there. And just in case you have missed that, you can connect to Mr. Kannan. Before we start the day with the technical sessions ahead, let's give this day a delightful spiritual start. And for that, for 1 minute, we are going to have Gayatri Mantra over here. So everybody, let's fold our hands, close our eyes, and dive into the spiritual journey of this wonderful session coming up ahead. Can we have the shloka, please?
Om Bhuvasvaha Om Tat Savitur Varenyam Bhargo Devasya Dhimahi Dhiyo Yona Prachodayat. Om Bhuvasvaha Om Tat Savitur Varenyam Bhargo Devasya Dhimahi Dhiyo Yona Prachodayat. Om Bhuvasvaha Om Tat Savitur Varenyam Bhargo Devasya Dhimahi Dhiyo Yona Prachodayat.
All right, gentlemen, with that, let's invite the first speaker of this fantastic day of learning on the stage. He is from Grasim Industries Limited, Aditya Birla Group, and the topic he is going to discuss his knowledge with us is Waterborne Epoxy, driving the future of sustainable resins. Everybody, please put your hands together for Mr. Gajanan Joshi, and I request Mr. Ashay Mehta to accompany sir. Everybody, let's cheer up Mr. Gajanan Joshi coming over the stage, taking this day ahead. Mr. Gajanan Joshi, General Manager, R&D, Advanced Materials, Speciality, Polymer Group, Grasim Industries Limited, Aditya Birla Group. Born in 1969, Master in Organic Chemistry from University of Pune in 1991, around 33 years of experience in polymer and various types of resin synthetics. Hand-on experience in formulations, resin synthetics like polyester, polamide, polamide imide, polyurethane, polyura technologies targeting applications like coating, composites, indulation technology and automotive coatings, working with Aditya Birla Advanced Materials since last 2021 February. Prior to Aditya Birla, worked with organizations like Huntsman India, BASF India, Eastman India, DSM India, Richard Point, Elathas Bat and National Chemical Laboratory NCL. Once again, we would like everybody to put your hands together for Mr. Gajanan Joshi.
Good morning, everyone, and thanks to Irma to give me this opportunity and Grasim Industries to present our product portfolio over here. Today, I will be taking you to the introduction of what is Aditya Birla. Hope don't need much introduction, and what is sustainability for us, and what are our products offering in that spectrum. So today's agenda is just an introduction, what is mean by sustainability to us, where we play a role in different routes of the sustainability, and what are our product offerings into the waterborne coatings. So as everybody knows, Aditya Birla is a very well-known group having a business of 60 billion USD, present across 6 continents and presence into almost 36 plus countries. We are very strong into the manufacturing, having 130 sites all over the world, with the employees as 140,000 of 42 different nationalities. We are into very diversified business. We are into the metals, cement, telecom, acrylic fibers. As we are into the chemical industries, textile industries, and apparels. We are also into the insulator, and we are one of the well-known industry in the financial segment. Aditya Birla has a leadership position in aluminum, like novelist one worldwide. We are third largest cement manufacturer in India. We are number one in caustic soda and specialties in India. We are number one in carbon black. We are fashion yarn manufacturers and as well as apparels in India. We are leading telecom provider and leading financial solution providers in India. So, few words about advanced material. Advanced material is a part of Aditya Birla Grasim Industries Limited. We are amongst top 3 specialty polymer epoxy players in India. Globally, having a presence of global manufacturing, India, Thailand, and in Germany. We are certified with Gajanan Lloyd certification. We are state-of-art R&D presence in 3 different continents. We have won recently the JEC award this year and in 2020 for into the composite shows. So we are also pioneer in recyclamine technology, waterborne epoxies, and green products. So where we play a role as an epoxy manufacturer, we are mainly into the composite applications, then construction chemicals like coatings, waterproofings, and tile adhesives. Then we are into presence into the coil coatings. Our epoxy goes into the coil coatings. We are also into the industry coating, very well-known player in the industrial coatings in terms of the amines as well as the epoxy products. We are also into the adhesives, and we also have business in electronics and electrical. So we make potting compound. We are into the potting compound as well as into the electronics. So Aditya Birla entry started in the epoxy in way back 1992 in Rayong site, where the first plant was set up. In Rayong, we manufacture liquid epoxy resin, solid epoxy resin, formulated products, and curing agents. We also have there an R&D which focus on the novel epoxy coatings, building blocks, epoxy building blocks, waterborne coatings, and mainly application or excellence center, I will say, for the composite resins. We also have state-of-art plant started in 2013 in Bharuch in Vilayat. Very recently, about a year back, we have done the expansion of a plant, and there we manufacture our liquid epoxy resins, some amine hardness and diluents. In 2013, we purchased a company called CTP in Germany, which has got a manufacturing site in Russelsheim near Frankfurt. This company was mainly into the formulated resin, liquid resin, and into the epoxy curing systems. We also have their R&D site, which takes care of the coatings as well as the composites, formulated product in composite. We work there into the waterborne coatings, high solids coatings, for the particularly focused on to the European applications. And lastly, we have a site in India, R&D site, which is based in Aditya Birla Science and Technology Center in Taloja. We work there. We have 4 groups there. a synthesis group which works into the resins as well as a curing agent system, synthesis of curing agent system. Then we have customized coating systems. We have a water-based formulation system. We develop over there the composite and electrical insulation formulated product, particularly focusing on the Indian industry. And we also have a composite and can coatings development center in that. The lab is a Gajanan Lloyd approved lab. So coming back to today's topic, why sustainability? Yesterday also we heard global warming, temperature rising, and we have seen the change of season experience in the recent past very much. So the major cause of global warming is greenhouse gases, and out of all many greenhouse gases, carbon dioxide is the main cause of this greenhouse effect. And this carbon dioxide emission is the major problem right now, and it is happening due to the burning of the fossil fuel. The way to reduce the climate changes or greenhouse gases is to the reduction or reducing the greenhouse gas and its emission. So Aditya Birla also focused into sustainability and is working on the reduction of the carbon dioxide and greenhouse gases. We have our own way to answer it. We work in different way to resolve this issue. One of the way to find a solution is we have a product or we work on water-based technology and other ways to do it. So I will just take you to what are the other ways, how Aditya Birla is addressing it. So there are two types of economy or two types of ways to answer or reduce the carbon emission. One way is called as C2C or cradle to cradle, which is called as a circular economy. In circular economy, we use fossil fuel to make goes through manufacturing and pass through uses, and then at the end of the life cycle, it is bring back to the again manufacturing. So we blend few products into it and we reduce the consumption of the fossil fuel. That is one of the way. And in that, Aditya Birla also plays a role. We have our own green product based, epoxy is based on the green technology, and we have developed a recyclable technology called recyclamine epoxy. So this is the way to cater the circular economy. And linear economy, which is also called as a cradle to grave, where after the use of at the end of the life cycle, it finds into landfilling. But the way we reduce the carbon consumption is by using a green epoxy product or water-based technology or high solids. So we have product in epoxies as well as into amine hardness, which are based on the water-based technology. So what are the silent features of Waterborne technology we have is we replace or we minimizes the use of emulsifier, increase use of water into the formulated product. It is the formulated product or dispersions or emulsions are highly stable, which has got a very good mechanical properties. They are eco-friendly or have a very less VOCs. It is easy to formulate this product, and we can optimize its applications and use of those products. So water-based epoxy characteristics, it's a mainly two-component system we promote here. We have a hardener based on water-based epoxy. So it's a two-component system. One has to mix just before the applications. Then the product is emulsion based and which can be further diluted based on the application requirement. No need of any emulsifier, so you don't need to add any extra emulsifier to it, and the performance of the product is equal to our normal solvent-borne coatings. So I will take you to the product offerings what we have. So this is the way we have two types. In one type, we have amine-based product where we can use along with the standard epoxy, mix it together, apply, and it will dry. In another route, we have two components. One is water-based epoxy as well as a water-based amine hardener. Just mix it and apply it. So I will take you to the water-based epoxy amine systems and general guideline formulation. So we have a product called THW4508, which is a 70% base aqueous solution, amine solution. So which is gives features like fast reactivity, short pot life. It has slightly higher color, but faster strength development, and it is contains slight amount of the formaldehyde. So we suggest a system like 4508 and Citipox 440-72. We just discussed about 4508 features. So property, it has got amine value 300, 320, viscosity 25,000 to 30,000, solid content 70 plus minus 2, and AHAW around 200. Citipox is a white milky emulsion with viscosity of 300 to 1300 centipoise, epoxy equivalent of 270, and a solid content of 72. So we have worked into lab and made a formulation, white water wipeable epoxy grout, tile grout formulation, which the formulation you can see over here. Formulation you can see where we have used along with the water-based epoxy resin. The silent feature is that both are the water-based resins. It's a three-component system where you can add the fillers afterwards. It allows higher filler loading. It develops strength very quickly, and it has a high strength compared to the cement. We have another product, water-based epoxy resin, Citipox 484R. It's a water-based dispersion, epoxy dispersion. It has got a very low viscosity, high molecular weight, provides longer pot life, provides faster drying, and typically, I will say that pot life has not ended, so you have got extended pot life to use, and it is a two-component based coating system. It is always used can be used along with the 4508. These are the typical properties of Citipox 484. Equivalent rate of around 490 to 550, and solid content 50 to 55. So when we use this epoxy, when we use the 4508 with standard epoxy YD 128 or 127 and Citipox 484, one typical thing we observed is that the drying time or hardening development is much faster into a two-component system where we are using water-based system compared to the YD 128. So one, we have a standard epoxy system, and another we have a water-based system. So our observation is that when we use both as a waterborne system, it develops hardness much faster than our standard system. This is a guideline formulation for 2-pack civil application with 484 and 4508. The pot life, as you can see, is more than 4.5 hours, but same time, the drying time is just 2 hours and 15 minutes, and touch dry time is just 80 minutes. So it is that fast hardness development happens, drying happens. So we also use our 4508 and 848 just to demonstrate the development of hardness. And when we use a clear system as a primer and fill system as a top coat, we see that the 80% of hardness is developed, just 80 to 90% of hardness is just developed into the 6 days time. So the hardness development is very fast, and it has got a very good abrasion resistance. So I will take you to another product called CTPOX 2421H, which is a 50% solution of amine curing agent. It has a low color, then longer pot life, high gloss at high PVC, formaldehyde free, which is one of the most important property, particularly into Europe market, and it is used for the flooring coating, and it has got a very good high mechanical properties. So this is the typical formulation when we use along with the YD128 and in the thickness of around 70 microns. You can see the clarity of the product. Although we have developed, we have got gloss of 100, but just to indicate that how transparent it is. So here also you can see the hardness development in this when you use 2421H along with YD128. The hardness development is very fast. These are the typical formulations for white pigmented based on 2421 and YD128. We also formulated the pigmented one with red. So here you can see 2421 and YD128, the kind of touch dry time we get, the gloss we got, and the solid. So these values are fairly good and would be interesting for the end user. So I will also talk about few things about THW4509, which is primarily used as a water-based curing agent in self-level epoxy floorings. So this is the ultra-high molecular weight epoxy amine, which is provided as a 55% solution into the water. It is a pale yellow in color with the AHEW of 300 and viscosity of 5,000 to 10,000. Amine value is 124 milligram per kH. High molecular weight gives you ability to have a compatibility with many base epoxy resins, and when it is mixed with the epoxy resins, it forms a stable emulsion. High viscosity, fast drying, low viscosity and fast drying are with the relative longer pot life are the typical properties of this THW4509. So we can use a self-level epoxy mortar with the high filler loading also. There are two formulations where we have used the more coarser material with YD128 and a finer sand for the better finish into the flooring and mortar. So this is water-based formulation. These formulations are developed in-house in our laboratory. That's the reason I am sharing with you. We work with, use with YDFM 253 and 4508, 4509. This is the self-level flooring formulation, white formulation. And with standard YD128 and 4509. So you can see that in both cases that is easily miscible. You can have application viscosity with a longer pot life, and it gives you very good performance properties. So why Aditya Birla? Why you should choose, or why you can work with us, or why you would work with us is because of we have innovative culture at Aditya Birla. We are very focused to and work together with the customer. We have operational excellence. We are present in Thailand, India, and Germany. So we are present at least in 3 continents. Our focus is into the sustainability. As I mentioned that we have 3 different ways to answer or cater this sustainability. One is water-based epoxy, then we have recyclement technology, high solids, and we also have bio-based epoxy products. We have scale of advantage. We are number 3 involved in epoxy manufacturing, and we have strong brand image. Thank you.
First. I may request Mr. Asher Mehta to accompany our speaker over the stage and appreciate him with a token of appreciation. I once again request Mr. Asher Mehta to join up over the stage. And once again, gentlemen, let's put our hands together for Mr. Gajanan, sir, who has given wonderful remarks on the given topic. Thank you so much to our first lecturer, Mr. Gajanan Joshi. Moving ahead, we are going to invite our next technical lecturer from Uniform Synthetics Private Limited, and I may request Mr. Vikrant Pajaria to accompany our next speaker. The subject given is Epoxy Ek Premkatha, and Mr. Vikrant Pajaria is going to bring up over the stage Dr. Rajendra Jaiswal from Uniform Synthetics. Everybody, let's put our hands together for our next speaker, Dr. Rajendra Jaiswal. I request Mr. Bajaria to hand over a beautiful planter to our lecturer. PhD in chemistry from UD-CT Mumbai, now ICT, with 24 years of varied experience. Chemical Technology Management CTM, currently with Uniform Synthetics, developing and promoting resins for paints, printing inks, adhesive application, works with Pidilite India Limited, CPMNT Coating and Adhesive R&D and PD. Component Graves Limited, Program Manager for Nanotechnology Chemical Polymer Group in R&D, experience in product development and technical service in various fields, consumer maintenance, paper glue, insulating materials, nanocomposites, functional coating and construction process improvement, cycle time reduction and cost reduction. Delivered presentations at national and international conferences, and he has been examiner at IIT, NIT and ICT Mumbai. We have with us Dr. Rajendra Jaiswal. Over to you, sir.
Good morning. So, Mr. Joshi has set the stage for sustainability in the morning. Great. I was starting this session, I was asked to give a topic. So I thought this is a group which loves and has lived the life with resins. So let's, when we look at something, which is, you like the more when you start loving the topic. That's why I put the topic as Epoxy as Premkatha. Epoxy is something which I have loved closely. Somebody must have gone with Alkyd or some other resins. So with that I start my topic. A brief introduction about our company, Uniform Synthetics Private Limited. It's a 46-year-old company, started by Mr. M.N. Chalawala. We are manufacturing resins for printing inks, polyamide, ketonic, polyurethane, phenolic, PVB. And then we are offering alkyds for paints, and malic and ester gum solid resins, and polyamide hardeners, basically for epoxy and phenylgumine hardeners. We have 3 locations in and around Vapi. These are our main location at Vapi, second at Silvassa and Sarigam. And here you can see our Chalawala ji with his central finished good warehouse there. A brief introduction given about ma'am already. As we saw yesterday, she did a good job to get everybody in the groove to the session. Same way I've started with a strong prelude. I hope everybody will come with FB. FB reminds you of what? Facebook, perfect. So these are the numbers. Like when we give a search on Google, you get a tool, like it gives you how many pages Facebook will appear on the net. So it is around 20 billion. So Donald Trump, the hot topic, what we talked yesterday, how famous is he? Our Prime Minister Narendra Modi. So chemistry, when we look at chemistry, it gets a very good hit, 2 billion. So now epoxy is also not so far. 1/3 of chemistry pages you can see on epoxy. And our famous SK and AK. Any guesses for SK? Salman Khan, and AK will be more Indian, Akshay Kumar. Good. So when I started learning it, my father also was in chemistry. He was also in resins. So when maybe I was maybe forced into getting into chemistry. But when came to chemistry, I started. It's good to relate chemistry when you start looking at it as a love story. So chemistry is all about love, making and breaking of bonds. When we make a bond in chemistry, delta G, heat of energy is positive. So that time love is there and bond is made. And when two people somebody comes in between and breaks the bond, you need energy to break the relationships. So there we have endothermic reaction. So it's about like making and breaking of bonds. Somebody is there, somebody comes and breaks, sometimes it's displacement or a replacement reaction. So I'll start my session with how we look at molecules maybe we have most of them of chemist, but maybe somebody, maybe non-chemist. So when we look at molecules, we look at them when we say H2O, it's a simple, but when we look in space or electron configuration or density, we have 3 different ways of looking at it. Then we come to our carbon chemistry. We can see how carbon is arranged and in different form, how it changes. It's more the bond length and other stuff. And then we come to our polymer structures. From basic chemistry to polymer structures, we have linear polymer, we have branched, aliphatic, aromatic, and then silicon chemistry. And then when we look at a typical aliphatic linear structure and a branched aromatic structure, the orientation in space. And a typical branched thermoset polymers, like when we say of epoxy or unsaturated polyesters. So my journey with epoxy started during my PhD when I worked on recycling, or given a project on recycling of polycarbonate. From there we converted polycarbonate to epoxy and made other polyesters based on those recycled products, and epoxy based were used for various applications. And then Crompton Greaves worked on epoxy based composites for insulation. Then I joined Pidilite. In Pidilite also we were working with different groups for epoxy. And currently I have come down from application to making hardeners at Uniform Synthetics. This is the conventional epoxy what we are looking at. Bisphenol A is because when we are using various hardeners, maybe amine, maybe phthalic based for high temperatures. So now when we look at sustainability, like what Mr. Joshi had told, here I'll be presenting, I'll be on 3 parts. How to improve the bio content of epoxy, what we are looking at. So when we are in this presentation, I'll be taking cardinol as a base from where we can make various molecules which can improve the bio content in epoxy. So when we try to go for a light color and color stable cardinol, one we can make phenylcarbamide hardeners which can be used in various epoxy systems, and there are other applications. In current presentation, I'll be covering towards epoxy based applications. So main objective was to have a light color and color stable cardinol from CNSL. Few Me Too products like what phenylcarbamide hardeners and other products which are available, either we can buy out or we'll be modifying going forward. So blocking and to get the color stable, there are 2 approaches of blocking cardinol with methyl cardinol, residol, and then color of distilled cardinol stabilized during storage. So these are the two challenges. So when we look at cardinol, these are the three sites with which we can play around to modify the molecule. So the first one is to get a epoxy diluent based on cardinol. So modification with epichlorohydrin, where we open the reactant and the open at the OH group. Second is by ethoxylation. And third, making di-epoxy from cardinol. First level, and then second we do an oxidation with benzoyl peroxide. Then we can have a flexible epoxy resin from cardinol. So this can be included in maybe phenylcomine or can be used as a epoxy modifier. And then cardinol modified epoxy resins for air drying applications. Here we can modify the basic bisphenol A based DGBA epoxy into air drying systems. Secondly, we can also prepare cardinol based epoxy and then modify the same along with cardinol, so that again we have an air drying system with higher bio content. Or we can, third step, we can maybe modify and incorporate silane and other groups in that, and then further use that system to make epoxy or other diluents. We had done these studies, like I'm saying, epoxy silanes and other are available. So on that same line, maybe modifying cardinol and using them into epoxy systems, which can give good adhesion and anti-fouling properties. So with this approach, we tend to make epoxy more sustainable. So if you look at the current bisphenol A based epoxy, the bio content is approx 0%. And when we go for this system, we tend to get a epoxy with bio content about more than 80%. So I'm saying this is what I'm discussing now. When I came here, maybe one of our university friends, he came and they were like trying to do an approach at their end where they wanted to increase the bio content with higher TG. So this can be some basis which can use to and maybe study their TGs and other property going forward to match those products. So after this, I'll be maybe like as part of knowledge sharing, I'll be sharing some case studies where as a resin manufacturer, when we go to supply resins and the problems we face and how we are solving those problems at times. So here are few projects which we have done in past. One is about like where they want to do a weight reduction using plastic composites. So where we have made epoxy and epoxy based nano composites and used them in electrical applications. So basically we have worked with certain agencies where they do a complete modeling of product. And based on the thermal performance requirement for the application. So there are the various 9 benefits what we have from when we go from metal to plastic replacement using any composites. Say weight reduction, part consolidation, productivity gains, labor savings, balance of properties, reprocess. Here, major role is played by reinforcements when we are doing. So either we have a natural or man-made and many varieties of commercially available glass fibers which are used. An ideal example is the bulletproof glass, what is there used. There we have epoxy-based systems which give those good properties. So the various fibers which are used is aramide, boron, carbon, glass, nylon, polyester, polyethylene, polypropylene fibers which are used to give a very good composite systems. Here you can look at the property and basically it gives about the density, like the weight of steel as compared to the glass fibers what we are using. Say it will be around say 4 time increase, 4 time weight difference is there, but the properties what we get are fantastic there. So the strength given by fiber composite made using e-glass aramide is around 10 times, maybe 8 to 10 times higher as compared to steel and aluminium. So here we can look at the property difference when we use a mild steel as compared to MS, compared to epoxy based composite systems. Or when we go to a Kevlar and carbon fiber, they are further increased. So this sort of systems we try to incorporate when we are doing transformers for in-house. Like when we have a transformer which is based in, say, a normal transformer, if you see, you have an oil-based transformer, which is normally kept outside. But when it's a shopping complex or a public area, they need a transformer where the fire, the probability of fire is less. So there they're trying to use a dry tap transformer, and there you are using epoxy-based composite systems to make the housings and insulating systems, which gives a working, sustains the working temperature and gives the required electrical property. So a small example about how a metal to composite application can be used by anybody at home, or it starts from here and it can go up till the level like what we are using in aerospace and other industries also. Second, one interesting work we had done was about using unsaturated polyesters in instrument transformers. This, there was a challenge here ki when we were making these transformers, they were sustaining in maybe locations like Maharashtra, or we make any product, it has to go from, say, when we give it to a place like Kashmir, the temperature is goes below zero. And we look at Rajasthan, the temperature goes to 45. So we need a product which can sustain from that the complete temperature range. So in that case, when we were making instrument transformers, which are again oil-free. So if you can see this as a site, so normally you can see a lot of instrument transformers which are there, which are based on oil. So there was an effort to convert from oil-based to solid-state instrument transformers, where we don't have any replacement of oil or oil leakage leading to other problems. So these were the oil-based instrument transformers. So these were replaced by polymer concrete-based systems, which could give the required electrical breakdown voltage and temperature sustenance and ruggedness, so that when they are put it in a maybe a electric substation, they can stay there for long. But the major problem was these structures are not stable. Stable in the sense mechanical stability was a challenge there, because being unsaturated polyester or epoxy systems, at times we should have shrinkage issues. As I told earlier, it was working from, say, minus temperature to positive temperature. So as in general physical phenomena, any matter expands on heating and cools and shrinks when cooled down. So there we had a problem of like these unstable structures. When they were going to cold countries, they were giving crack issue. And secondly, when there were twofold problems. The one is about shrinkage at minus temperature, and then when we were casting these products at in different time frame, like when, say, okay, I'll take it further there. So we did some publications on that. So then we had a system where we used to check these systems before sending at minus 25 degrees Celsius, minus 5 to minus 15 to minus 25. So the challenge was when during testing they should not crack this system. So we had some products which were made during maybe at in winter season. Those were cracking a lot at minus 5 to 10 degrees, and then when we were sending to geographies which were going further minus 25 degrees, there also we were getting different cracking issues. So there were twofold problems. So when we looked at the complete process of how the casting takes place, this factory was located at Aurangabad. So Aurangabad, we studied the complete. We had tried to have a 360 look at the complete plant, and there we found that Aurangabad has a temperature from say 40 degrees to -8, sorry, not -8, around 8 degrees Celsius, sorry, during winter season. So when we, like in unsaturated polyester, you have polyester, along with that you have styrene as a diluent. And this was a, vacuum casting process. So when we were casting it in winter season, as we look at the temperature, the styrene part removal was less during winter as compared to styrene when we are casting in summer season at 35 to 8 degrees Celsius when you look at this temperature. So when these castings were done in winter season, it should have a lot of residual styrene inside, which due to that, these products when they were made in winter season and sending to geographies around 5 to around say sub-minus temperature only, -5 degrees, those were cracking there. So this problem when we had, so we looked at the complete temperature, where we studied that due to lower temperature castings, we may be having these problems. So then we made arrangements so that we can do the casting during winter season at 25, at ambient, say ambient of 25 to 30 degrees Celsius. We found those products to be stable, and then they were tested in the same condition, and we found that those products are stable. That's how one of the problems were resolved. Then the second issue was how to take it further, -25. During that time, we were given a mandate to do nano-composite projects. So that's how we got a complex, unstable to stable structure. And when we looked at, we had done this project with nano-composite with clays. So this samples, when we had run a DSC sample from say ambient to -40 degrees Celsius, we found that there are two phase changes which are being shown at -5 and -25. And when we did the same DSC run with nano clay based composite prepared, we found that those two phase changes are removed there. And thus when we had this product, we tried to use this nano composite, nano clay based polyester for casting. And then again the same thing was tested at -25. The first phase was to test at -5. Then the test was made more stringent to -25, -40 degrees Celsius. We found the same product to be stable at those temperatures. So that's how we got stable product from say ambient 25 to -40. This was working till -25. We were able to make it non-cracking product, and this was then exported to geographies where we were not able to export beforehand. So that's how again we call it a bit magic of nano when we did this, and we are able to get Napocrete, and we named it as Napocrete, nano composite based polymer concrete as Napocrete. So we had a high reliability, lower weight, and flexible and maintenance free eco-friendly product. Secondly, when one more third case study I am talking about is use of simulations and modeling while doing a polymer to metal replacement. So we had made, there was a nozzle which was maybe a metallic in nature, which was to be replaced by a Teflon based system, whereby the team needed when we are giving this to technical team, the mechanical group were not satisfied that this white can be a weak zone. So before putting into action, we did a complete simulation of bursting strength using ANSYS as a software, where we had put all the mechanical properties of Teflon composite based on Teflon and MOS2. And the same structure was physically tested with hydraulic pump and then validated. So this way we made a jig. With water pressure, we are able to test the pressure at what pressure it bursts. So this was the simulation done, and with simulation we found the section in blue as the weakest zone, and the white section which was there. So green basically shows which is stable, and the blue one is the danger zone. So while doing this, it happened in such a way that Teflon as a material, it is not so possible for us to burst with that water pump. But when we did it was by mistake, it was left, the pressure was left by the casual worker. And when we realized, when we opened, we saw there is a deformation taking place. And the measurements were taken. As you can see, the threaded part showed the maximum the deformation of size. So that's how we were able to validate that the white, where we are basically doing a sandwich of thermoplastic, is not the weak zone. And we are able to use a simulation technique here. So these are the few new simulation techniques are also now being used in plant to identify maybe leakage, or when we are designing new products, we can use those techniques. So with this, we were able to get that section 1 in the weakest zone. With these 3 case studies and sustainability point, I end my lecture here. A big thank you from the team of Uniform.
Thank you so much, Dr. Rajendra Jaiswal, for your insightful remarks on the given topic. I will request Mr. Vikrant Bacharya to come over the stage and hand over a token of appreciation to Dr. Rajendra Jaiswal on this auspicious event.
Hey, good morning, Raju.
Okay. Yes, sir.
Hey, nice lecture. One correction actually on your slides. You said that epoxy 100% non-biodegradable. That's what you said. Bio-content, 0 you are written.
Yes, containing...
Normal epoxy you said 0, and
yes.
cardinal containing you said about 60%. So it is not so. You can correct it because nowadays epichlorohydrin comes from glycerin.
Okay.
So which is bio-content is there. So you get 34% bio-content for normal epoxy also. Okay. And that's why I'm saying, so if you are using cardinal base, probably your bio-content will go up. So have you tested that bio-content in any laboratory?
No, that we were discussing about some NMR test is there, which can trace the particular carbon compound.
No, Raju, don't worry. That's what this
is what I've given.
You just reply me. If you are tested, yes. If you are not tested, tell me no. Then I will help you to test it. Okay?
Sure.
Yeah. Chalo, thank you.
Okay. Thank you, sir.
Nice lecture, and you have taken everybody towards the simulation techniques on the thermoplast and thermosets. Jaiswal, the epoxy is bisphenol A and epichlorohydrin. As someone said, epichlorohydrin, glycerin base, so it's okay. But the bisphenol A is a danger, bisphenol, BP content. So I don't see the life of epoxy if it is BP. Bisphenol content in plastic is under radar.
I know.
At US FDA. So unless it is hydrogenated bisphenol A, I think we should not proceed in epoxy. That is actually a word of caution as an elderly man. Thank you very much. Yeah.
Thank you.
Subhash, what you are saying is hydrogenated bisphenol. Hydrogenated bisphenol will not give you that kind of an hardness today. The epoxy resin gives hardness because of the closed ring structure. Okay, if the aromaticity you remove that, it will become a very flexible epoxy. It will never give you that hardness. Towards that, you have bisphenol F resin is there, which is not so hard. Yeah.
No, my suggestion was to Jaiswal was, when we talk epoxy, वो तो मोहब्बत की दुकान खोले बैठा है, समझे ना? तो
सबकी मोहब्बत की दुकान है सर, हमारी नहीं है।
तो मोहब्बत की दुकान है, तो उस मोहब्बत की दुकान में मुखौटा लगा के कोई चीज़ बेचनी नहीं चाहिए। सच्चाई की बात है। आप सत्य के साथ रहें, धर्म आपको खोज लेगा। अगर धर्म नहीं खोज पाया तो धर्म की प्रॉब्लम है। आप सच्चाई के साथ रहो। तो उस बेसिस में आपका स्टेटमेंट ओपनिंग रिमार्क होना चाहिए जायसवाल जी कि बिस्फिनॉल ए इज ए रडार, ऑन रडार, यूएस एफडीए। पूरी दुनिया में कार्सिनोजेनिक, मेटाजेनिक और रेप्रोटॉक्सिक है। सीएमआर स्टेटस रेंडर्ड है उसको। अब जितने लोग निकल गए, सीबा निकल गया, पागल थोड़ा था सीबा, छोड़ के चला गया इपॉक्सी, वो समझा ही नहीं सकता। और जो ये बोल रहे हैं ना सामंत, बिल्कुल ठीक बात है कि उसमें वो हार्डनेस आ ही नहीं सकती, क्योंकि हाइड्रोजनेटेड जब आपने सेचुरेशन को, उसके प्रेम को तृप्त कर दिया आपने, आपके बिस्फिनॉल ये को तृप्त कर दिया, तो फिर अब वो हार्ड रह ही नहीं गया, वो तो प्रेम की दुकान हो गया ना, खुद ही मोहब्बत की दुकान हो गया यार, नहीं समझे? तो वो उसमें बिस्फेनॉल एफ करो या ए करो या जो भी कुछ करो, बट अल्टीमेटली उसमें उसकी कार्सिनोजेनिसिटी का जो रूट कॉज है दैट इज दी बिस्फेनॉल, बीपी। अब तो निपू आएगा, नॉन आइसोसाइनेट पॉलीयूरेथेन, देखो क्या होता है।
So, just to add, like while preparing for this session, I also went through like what are the negative effects. If we talk that epoxy is risky, so when we are looking at the other applications where non-critical applications where it is not getting interface with human being directly, say like construction or coating on metal surfaces, it is still, I'm saying we have to stay with epoxy, bisphenol A based epoxy.
राजेन, मैं तो बोला ना, तुमने बोला प्रेम कथा, अगर प्रेम कथा नहीं बोलते, मोहब्बत की दुकान नहीं खोलते तो सच्चाई की बातें ही करते, सब सेल स्टॉक करते हैं। लेकिन सेल स्टॉक नहीं करनी है, तुम्हें सच्चाई बतानी है, सच्चाई बयान करना है, मोहब्बत की दुकान खोलनी है, तो बिस्फेनॉल ए इज नमस्ते, ठीक है ना? ओके
ओके सर।
तो वो नहीं है, नहीं है।
As a coating guy,
नहीं,
okay, into the resins. The resins.
छिपा के रखना पड़ता है, उसके ऊपर PU रखना पड़ता
No, that is there. See, going for a PU, okay, that's the best possible thing. But certain things which need an epoxy.
It has only chemical resistance. It doesn't have exterior durability, light pass, weather fastness.
Agreed, doctor. A full agreement to you in terms of that it doesn't have an exterior durability, it doesn't have a light fastness, another thing. But what is it that an epoxy can give which is different?
इपॉक्सी के बारे में सब कुछ खुली किताब है। 1950 से भी 75 साल हो गए यार, है ना? द प्रोडक्ट लाइफ साइकिल इज नाउ कैश काउ। कैश काउ समझते हो? इसमें कोई इन्वेस्टमेंट नहीं है, जो हो रहा है वही करते चलो। इपॉक्सी डजंट हैव व्हाट यू कॉल एक्सटीरियर ड्यूरेबिलिटी, यूवी रेजिस्टेंस, लाइट फास्टनेस, वेदर फास्टनेस। तो फ्लोरिंग के ऊपर भी अगर आपने अंदर कर लिया 400 माइक्रोन का थिक लिया, ऊपर आपने 2 के PU का क्लियर कर लिया, वो छिप गया। जैसे आपकी अंडरवियर छिप जाती है आपके अच्छे ट्रेवेरा ग्रेसिम की शर्टिंग शूटिंग से, एग्जैक्टली वही करना पड़ेगा इपॉक्सी में। और जहाँ इसकी ज़रूरत है वहाँ करना है, हर जगह मत घुसड़ो इपॉक्सी, ठीक है ना?
So we can have a good panel discussion on epoxy.
In the evening. In the evening we can have it.
Post 8 o'clock, Dr.
Post 8
Jaiswal.
o'clock, that will be better.
We'll have a panel discussion post 8 o'clock.
But Raju, you initiated some discussion. That's more important
Yes,
actually.
very
That is
nice.
the job of a speaker.
नहीं, लेकिन मुझे इसके टॉपिक का जो शीर्षक है, जो उसका जो फेस वैल्यू प्रेम कथा, वो पसंद आई, इसलिए मैंने बोला।
नहीं, सुभाष का तो सब प्रेम पसंद आता ही है।
सब
तो
प्रेम
सवाल
पसंद
नहीं
आता
है।
और बोलते ना, बंद घड़ी भी दिन में एक बार काम कर सही समय दिखाती, वैसा मैंने टॉपिक तो डाल दिया था कि
हाँ,
कहीं ना कहीं तो अच्छा लगे।
अब दुकान खोल दी, सच्चाई बेचो। नहीं, इपॉक्सी में जब बिस्फेनॉल ए है तो उसका सब होगा, उसके अंदर वो जहर है वो है। But polyester is hydrolyzable, I'll tell you. It is hydrolyzable. So ultimately सबकी तकलीफें हैं. There is nothing which is foolproof. ईश्वर के अलावा कोई भी omnipotent, omnipresent, omnipowerful नहीं है. बस नमस्ते कर लो उससे को. हाँ. नहीं, सामत मैं 2 से 4 के बीच में मेरा क्लास है, तो I will be मैं नहीं रहूँगा 2 से 4 के बीच में, बाद में करना. Between 2 and 4 I have a class, so normally. हाँ, 8 बजे करो.
Thank you so much, Dr. Rajendra Jaiswal, for opening gates for this panel discussion, which might be possible after 8. For now, I will request Mr. Vikrant Bajaria to hand over the token of appreciation to our speaker from Uniform Synthetics Private Limited. His topic was Epoxy, ek Premkatha, and we all are grateful towards him for putting these remarks over here. Thank you so much. With that, everybody, we are going to proceed ahead towards a short and sweet tea break. So we are going to take 10 minutes of our time towards the tea break session. Afterwards, we will continue with the next lectures. Next speaker from Allnex Resin India Private Limited. He's going to share his knowledge over the topic given UV and high solid technology, latest trends and applications. Everybody please put your hands together for Mr. Supratim Chattopadhyay. Let's welcome Mr. Chattopadhyay over the stage, and I request Mr. Bhagesh Narkedi sir to proceed with a beautiful planter. Mr. Supratim Chattopadhyay is Technical Service and Business Development Manager at RAD INSC. Sir has an impressive background with 20 years of experience in radiation curable inks and coatings. His educational qualifications include a master's in organic chemistry and an MBA with specialization in marketing. He began his career in 2004 with DIC India Limited and currently working in Allnex Resins India Private Limited, where he has taken on various roles in product development and technical support. His experience span across radiation curable products and applications including ultraviolet, electron beam and LED technologies with applications in conventional LED, OLED and photovoltaic cells. Everybody handing over the stage to Supratim Chattopadhyay.
Good morning everyone. So on behalf of Allnex, today I will going to present a topic based on UV curable products as well as the high solid resins, which is used for various recent trends and the next generation applications. So in today's session I will going to cover, is it working? It's not working. No, it's okay. ये वाला? Yeah, so we'll just talk about these following items. So first of all, before going to the main session, I will give you a brief idea what Allnex is about. Many of you might be knowing us, but still we would like to introduce and what we are doing at the moment. Secondly, the radiation cured technology, which consists of like UV, EB, LED and all the next generation types of applications and technologies, the latest offerings that we have in our basket. Then we will go for the niche applications, which are very new, but in somewhat it has been already we have seen in Asia, but is still coming in India at the very nascent stage. So we will focus on that too. And lastly, then we will discuss on the high solid resins and the latest developments, so an advancement on that. So Allnex, we are the global leader industrial coating resin company #1, and our headquarters is based on Frankfurt, Germany. Our manufacturing footprint consists of around 34 manufacturing sites across all geographic locations. And if we talk about our technical strengths, we have around 400 scientists and technicians who are working around 24 R&D labs across all leading positions and across all the major areas in the globe. And very recently, we have also added another R&D center in India. Previously, we only had the technical service and development lab, but now we also added another high-tech lab, which consists along with the capabilities of the synthesis as well. Now, looking at the trend in our region to further strengthen the manufacturing capabilities as well as to further strengthen our supply chain position, we did some investments in this region. So first, if we say in India that the first plant we are now coming up, that we had taken over the old plant of DR coats and resins, which is in 2022, but now it is in the expansion mode. And by Q3 2025, it will be ready, and it will be as per the global standard what Allnex produce. We have all the products from this plant. And basically we will produce like all the chemistries like acrylics, alkyds. Acrylics, when you say it will be solvent bond polyesters as well as the water bonds. Then we have some of the cross-linker products as well as some the radiation cure products as well. Secondly, another plant is in the Jiaxing, China. This is by far the largest plant that we will have in Allnex basket. So it is the huge plant which is having around 16 new pilot reactors. Half of it is already converted, so and it is in the expansion phase. By next 1 or 2 years, we will complete this expansion as well. So from there, we also produce all these acrylics, polyesters, alkyds, powder coating resins, UV products. UV, when we say it is including the 100% UV as well as the waterborne UV and some of the cross-linkers products. And third, that is the rayon side. I think Aditya, Birla, in the morning also we heard they have the plant in rayon, so I was a bit surprised. I was not aware of that. So we also have a big plant in rayon. Generally, it is mainly meant for the powder coating resins, and there we also make some waterborne acrylics. And now we are in further expansion mode, which will be very close to our parent company, that is PTTGC. As I said, just early this year, 2-3 months back, we just inaugurated our new synthesis and R&D lab in Mumbai. Previously, we were only having half of the floor, which consists of the application development activities. But now we have expanded 1/2 floor for the powder coating resins application and development, and 1/2 of the floor is fully for the R&D synthesis. So now if you look at the synthesis strength, what we are at the moment now develop, that is we have different kinds of chemistries now we make in India as well. So we don't need to be dependent with our overseas parts. So we can make all the polyesters, acrylics, and whatever chemistry we produce, everything we can produce locally from Indian lab. Now, along with that synthesis capabilities, we have developed our analytical strength as well. So when you are working in synthesis, we have to have analytical strength. So in that, we have also invested in all the equipments which are as per the latest standard. So we have up our FTIR, GCMS, DSC, all the things which is required for any kinds of characterization of any types of resins what we produce. And when you say the technical service, we are already there for all type of applications, whether it's conventional as well as UV. So now we are also ready with the powder coatings. So now we can say we are almost complete with respect to the R&D and technical strength. The business, how we operate, generally we are split into 4 business areas. It's mainly like liquid resins and additives is one of the segment, radiation curable resins, cross linkers, and powder coating resins. So when you say the liquid resins, that is more like all kinds of solvent-borne chemistries and water-borne chemistries, as well as a conventional technology, which covers all kind of wood coating, industrial, metal, and automotive, of course, one of the big segment, flooring, and all these things. When we say rad cure, radiation cure, we have the oligomers, monomers, waterborne as well as 100%. Under oligomer, we make all the epoxies, polyesters, urethane, as well as some specialty urethanes and silicone acrylates. And in rad cure, packaging is one of the major segment. Apart from that, we also cater to the plastic industry, then industrial wood, metal, and of course the new generation technology like composites, 3D printing and all, which we'll discuss in the next stage. Cross-linkers, mainly the amino and formaldehyde free with formaldehyde, some low formaldehyde, so all types of various products we manufacture. These also go for can coating, then you have the coil, metal, all these types. And also we have some phenolic resins and technical phenolics for the rubber and tire industries. Powder coating resins, there also we have the polyesters and hybrid polyesters we make, and even in the next stage we also have the low temperature cure, low bake, so we cover all the spectrum. And there also for the architectural, this goes for the domestic appliance, general metal and all these segments. So I'll give you a brief idea about what is radiation cure technology is all about. Maybe a few of us already know that, but just to refresh that, in general, when we discuss of the conventional technology, mostly the classical drying happens through the evaporation technique. In some cases, it has been some cross-linking with presence of some catalyst or some reactive agents. Whereas in case of UV curing, there is no need for the exposure to heat or oven. You don't need to pass it through oven. It is mainly happens through the radical process, which comes under the exposure of the UV light or radiation. And generally this UV exposure is done through the using of a mercury vapor lamp or some LED and low energy cure systems. So when this exposes to this liquid phase, directly the photoinitiator molecules, which is one of the constituents of this formulation, breaks down and it helps to the further doing the polymerization of the system. So you don't need to put any oven or heating system into it or IR chamber. It has some definite advantage. If we see that there is a significant reduction of energy consumption, the reactivity is extremely fast. You don't need to put an oven for maybe 30 minutes, 40 minutes, whatever you say, but it happens within milliseconds. So for the cases where we need high productivity, UV is the sure solution. Packaging is one of that application where you need significant speed of production, so UV is very successful in that. As well as for the plastic industry also, UV is now very popular. Optical fiber industry, now because of the digitization, you cannot make with conventional thermal epoxy, where you need to bake, significant time, you have to use lot of power. So in that case, this optical fiber industry has completely switched over to the UV because you have to make kilometers and kilometers of optical fiber cable within the day. And also there is a low VOC, of course, because there is no solvent, and also it is a definite had some advantage with respect to compliance. Now, if we see the market shift of even the radiation cure technology, initially we started with the mercury vapor lamps, but with period of time, mercury becomes, it's a heavy metal, so there is a lot of, negative aspect this carries along with it. So mercury has becoming always a matter of discussion, maybe banned with, down the line after few years. So then we don't have the choice of UV generation. So then it goes for this electron beam and the LED. So in the red points, if we see the bullets, though these are the negative aspects what we see for the UV curative. So there we have the PI concentration, high mercury vapor lamps, these are the negative aspects for standard UV. So if we want to move to the EV system, there you have the advantage that you don't need to use a photoinitiator. So you are just eliminating one of the negative aspects. Similarly, mercury also you can remove. But in case of EV, there is certain negative aspect also. It has a high expense, high cost, capex involvement is there. And secondly, the maintenance of the machine is bit expensive. And you also need some nitrogen or inert atmosphere while doing this. So now the industry is trying to move away from EV also. I mean, they wanted to move out from EV to something new. So there is requirement of energy saving, slight bit of removing of the mercury, that you are no need of a mercury. So it is going towards the LED technology, which is called the low energy system. And in LED, it is extremely fast. But of course, there is a limited photoinitiators availability are there. But as a formulators or all other suppliers, they are working together to come up with different solutions which can meet the requirements or the technical challenges. And few are, of course, there in some unconventional applications. There is some thermal and peroxide based curing is also been used, which has been as a hybrid mode to use the UV material as well as with the conventional system, and where the drying or curing happens to the peroxide. So in case of LED system, when we do the formulation, you face certain challenges. There is the reactivity is need to be controlled with respect to using of the photoinitiators, but we have some limitations in the photoinitiators. So in that case, oxygen also plays a negative aspect. It gives some inhibition, or surface remains a bit tacky. So in that case, we have certain booster resins, which is mainly the amine modified polyethers, or in some mercapto modified, which has been used as a booster resins for the LED curing formulation. LED 03, 04 and 05, these are the main flagship products we have with a different viscosity levels. So first and the bottom one generally used for the low viscosity applications like flexo and even screen and gravure type, whereas the middle one, which is 04, this is the high viscous products, mainly goes for the litho application. And another advantage these three products also has, it can remove the utilization of this EHA or EDB. So it's kind of amine based products. So it can be moved out from the amine based formulation to non-amine based by using this type of LEDs, booster resins, which are mainly effective in the range of 365 and 395 nanometer of a wavelength lamp. In case of photo initiators, there also has certain challenges. Mostly the photo initiators are low molecular weight. So what happens in case of indirect food packaging, when you go for the UV application, there is always a chance of migration. So how to control those migration? You have to go for a high molecular weight products. By nature, all the photoinitiators is mostly available in the market as low molecular weight. So you cannot control the migration. So we have to switch over to polymeric photoinitiators. But polymeric photoinitiators has a limited abundance in the market. Suppliers also, they don't have too many. In that case, we come up with few of the products which are not photoinitiators. These are mainly a resin system, but in build they have the higher reactivity compared to the standard oligomers or monomers what we sell or available in the market. So it calls as a self-curing acrylates. So we have LED 10101, Leo 10103. These are the two products. First one is for the low viscosity application and second one is for the high viscosity, as well as it can be used for general flexo and gravio type. And both of these products has a advantage that these are made with the GMP practices, so we can be used for the indirect food packaging. And it also complies with the German incontinence system. So anyone who is just exporting the rings from India to outside India, maybe in Europe or US, so we can comply with all the compliances which is required. Another very demanding application is the shrink sleeve application. Whenever we go for any kind of airports and all these departmental shops, we see lot of beverage and all these food juice, what we cans, what we get. These are all now wrapped with the films, is of highly brilliant qualities, which are very aesthetic appeal. Just to give a 360-degree view, most of the packaging now is going for the shrink sleeve applications for these kinds of beverages. So in that case, you need a oligomers which is having shrink capacity of very high levels. So maybe 50, 60, 70% of shrinking capability it should have. So that after the application of the flexo ink, when it goes for the shrinking stage, it does not crack. And it does not generate any kinds of defects. So our 571 and 573, these are the polyester-based acrylates. These can have the shrinking capability up to 70%. So 573, the next level product, 57 was the first generation. Both can be used for any kinds of flexo printing. TMPTA is trimethyl propane triacrylate. Many of us might be knowing is a very common monomer being used for any kinds of UV formulation. It has very fast reactivity. But the unfortunate thing is that just recent years, the Risk Assessment Committee of Europe, they have banned this TMPTA and they have segregated under its carcinogen 2. So any of the formulations which we are exporting, or maybe the big band players which we are working, we cannot supply TMPTA in our formulation. And if it is above 1% in the dosage level, it will be considered as a carcinogen material, and the HS code has been changed. So if it is below 1% and less than up to 0.1%, it is still you can mention it in the SDS, but less than that, it has it considered to be very low residual, so you are free to use that. So in that case, Allnex, we have certain solutions like Ibicryl 853, 892. These are ethoxylated products, somewhat bypassing the TMPTA, but still it has a higher reactivity and can match all the performance what TMPTA brings in any formulation. Bisphenol A, yes, this is another topic. Is by name itself, it has now got all the negative comments from various industries, and people are a bit skeptic about using any of the products which brings bisphenol A into it. So we are not, we cannot be away from this demand. So we are also worked with various products which are bisphenol A free. So some are the epoxy acrylates which are made with the different chemistries which can move out from bisphenol A. Similarly, the polyester based products which are bisphenol A free, that is the Ibicryl 417 and 418. These are mainly the polyester resins diluted in different TMPTA free version monomers which can be used for any kinds of litho and other application, mainly for the plastic industry. And epoxy, which are bisphenol A free, that can also be used any kind of high reactive systems as well as OPB and inks. From linear to circular economy, again, recyclability is another big factor. So whenever we are doing the application of the ink, so demand is that on the plastic, there is a high demand that it should be recyclable. In that case, sometimes customer want that ink should be recycled, plastic material what has been used and the ink which is applied on that should be recycled or removed at the time of recycling process. In that case, if the plastic as well as with the label need to be recycled, then it has certain amount of alkali strippable performance. And the test performance is done, that's as per the Association of Plastics, that APR, we generally test along 2% NaOH solution. So our Evicril 577, these are product which can be used as an alkali strippable coating. And similarly, we have the products where you only want the plastic to be recycled, but ink don't need to be washed out. So we have the products which are alkali resistible as well. So based on the end customer's requirement or the brand owner's requirement, we can support you with the products. This is the test that we have done in our labs. So in both the applications, whether it's in packaging as well as the cosmetic packaging, where cosmetic generally it goes for the rigid plastics and flexible packaging, that's for the film kind of application. And in both cases, we have seen very nice de-inking property on the right side if we see both the pictures using this product. Now, few of the latest trends, the vehicle refinish, we know it is the strength of our colleagues. They have a big business into it, but still we wanted to promote our UV technology also in the vehicle refinish segment. The main USP is that these are the products which can be used as a sealer at top coat, like the first one, if you see the greener one, Evicril 8412 and 8501. These are the urethane-based acrylates which can be used for the sealer application. Both the products have very good adhesion with all kinds of SMC, aluminum or steel metal plates, and allows high filler loading, which is the best demand for any kinds of sealer. Also have a very good sandable performance. So any garage who is using kind of sealers which are conventional, if they switch over to these kinds of products, it will drastically improve their productivity on garage efficiency. Similarly, in the top coat, in UV, we are already present in the automotive segments for the headlamps in other areas. It is already a proven technology. So if we go for the top coat, we have this Evicril 4513 and 4680. These are the, again, urethane-based products, very high outdoor durable products and weathering resistance. And these also have a good chip resistance and all. So any kind of clear coats which has been used for the refinish application, it can be used, and these are also reactive with respect to LED as well as normal mercury vapor lamps. So we can go for standard as well as low energy curing system. So where you can use a portable LED lamps to cure some of the part of the components of the doors or outside. The next one is this in-mold decoration, because a lot of parts in the automotive now becoming interior application. These are although 3D shaped. So when we see for the thermoformable type of materials, they have a typical resistance with outdoor exposure and all. So there we have two products. One is 100% type, where like Evicril 8606, 8314 and 8315. These are the urethane acrylates. But the second ones, 4900 and 4950, these are kind of dual cure. 4900 is an OH functional products, whereas the 4950 is NCO functional. In case of 3D, after doing the curing, unless you are doing a spray process, but still there is a challenge in some of the curves and shadow areas, you didn't get the proper curing. So what we have proposed, that if we apply a flat surface and then do the forming, after doing the UV curing, if we do the forming, there is a chance of cracking. But in this dual cure technology, after the moisture evaporation, solvent evaporation, what we do? We do the forming, then we complete the process through UV curing. In both these cases, you have a certain elongation performance, like thermoformable 100%, you have 70 to 50, 115% of elongation, whereas for the dual cure, we have almost 300% of elongation performance, along with all the chemical stain which is required for automotive interiors. Now in the second stage, see the process first, the foil, which is the flat surface. Now we don't need the challenge of three-dimensional substrates, so we can coat the foil and you just wrap it. And because it is a tack-free surface, you can wrap it after doing this dual cure UV coating. And then in the next stage, when it is required, you just do the forming at 170 to 250 degree temperature and do the forming and UV curing and finish your job. So there we can omit or somewhat we can minimize the risk of cracking what we see in case of 100% UV. Comparison wise, if we see all this dual cure system, conventional or the regular thermoformable what we have in our standard UV range, which is have certain of hydroxyl functional or NCO functional, they still have some limitations. Whereas in case of dual cure material, it is extremely good, and you can see it can cover all this performance and much better than the 100% as well as the standard available dual cure materials in our UV range. 3D printing, this is also very niche applications, but in various segments, whether industrial as well as the medical, we see the demand of 3D printing because of it can print lot of critical things, complex designs, and if we see the images, few are very common to us, but mostly these have been done through this UV technology. In medical system, orthodontic is the most promising segment where we can make all the aligners and dental molds. And if you go for the industrial segment, all the prototypes now which has been made for as an industry use, along with these small toys, what we see in the airports and all, these are all made with in 3D printing application. Even the jewelries, the casting jewelries, they go now use the 3D printing process to make the final initial master, then they go for the all this bulk production. In these segments, we have certain urethane monomers as well as the epoxies. These are, of course, the modified epoxies, which can bring all the requirements or can pass all the technical challenges which it has, whether it is highly flexible or very hard type, which is even like ABS plastics and all. So we are working with many of the customers in India also. It's very good for us that they are also now ventured into 3D printing, which we can develop over the period. And another one, lastly, in the UV segment, we will say this is for the flexible packaging. But UV flexo become very dominant now. So there is a demand that when the printing is happening, so we see in past incidents that during the changing of the environment, the surface tension drastically falls. So you cannot get the good adhesion or consistent adhesion with UV inks. So now what we are doing, that the films, rather going for a only corona treatment, we are applying a waterborne UV on those films, and then these are the tack-free materials. So once we are applying and drying, only the moisture is evaporating. It is given as absolutely matte tack-free surface. You can wrap them in jumbo rolls and you can send it to the converters. They only print the UV flexo top on it, and they can do the UV curing in a single stage of the primer as well as the top coat. So basic advantage is it is VOC is one part, and secondly it gives highly brilliant surface and image quality when you apply with an UV, you top on in waterborne UV. So image clarity is the main USP of these kinds of products. All the labels now, high-end labels, even the medium segment labels, what I see is generally based on this technology. And these are all happening in India. So we need to work more on these areas. Now, if we talk on some of the regular and high solid resins, we'll go. The first one is for the waterborne enamel. So enamel is more, we know it is mostly dominated by the solvent-borne technology. So, but what we are proposing here is an oil-modified acrylic multi-domain product. So there is the residrol product, residrol acid 8002. So it is made in the base of the onion layer structure. So you have a 3 phase. So in the core and the domain, if you see, there is a different TG values are there. In between, you have the low TG material, whereas in the core and the outer shell, you have the high TG. So these products, along with the thermal performance, it also brings high solid. It is not like 30 or 35% solid what we see in the market. It has a 50% solid. And same time, it is waterborne, and it can be workable under all various temperatures from low to high temperature range. So all climatic situation we can use it. Similarly, it has very low MFT, so it is fast drying, we can say, and we don't need to be, wet too much for what happens in regular solvent-borne enamel system. And of course, it has an advantage with respect to VOC. Second one is the Setacova 164106. It is a self-cross-linkable solvent, waterborne polyester. Waterborne acrylic, sorry, I said polyester. So it is mainly used for wood sealer. In case of also sanding sealers, what we see is mainly dominated by the solvent-borne systems. So here what happens, because of the self-cross-linkable nature, it is bit fast reactive compared to the solvent-borne system, and it has a very good sandable performance. I mean, after the drying, easily you can do the sanding. So compared to the solvent-borne, it has definite advantage. Even it is a high TG material, and after the drying, you don't see the paper clogging on the system. Surfactant free and also amine free type. So it has the value with respect to eco-wise, or is a sustainability. Now, in this slide, we have shown half of the portion. If we go on the upside, so it is at the medium solid products, various range of medium solid products, mainly are the solvent-borne polyesters, which have a high solid of around 70%, even some are a bit higher than that, from low OH value to high OH values. So based on the customer's requirement, economics and all these things, we can select various products from this list, whether we need a high reactive, high durability, or the other performance, surface performance, we can choose from this and select the OH values which can be used for different auto and industrial metal applications. And because of the high solid nature, like even in the bottom side, if we see it has almost 80% solid, 75, 78% solids. So this helps us to reduce the number of steps being used for this automotive, like vehicle refinish stage. We are applying multi-layers. But in case of high solid, we can reduce the layers that we apply. So in some other way, it has improved the performance or productivity of the garages. Also, it has very fast reactive compared to the standard system. We don't need to wait for overnight for doing the sanding and polishing. We can finish the job each same day itself. Another, this is the fast cure resins. Previously we have discussed of the high solid resins, which are also fast reactive. But the FC series, what we promote here, these are even faster than these standard fast cure resin systems. The products are designed in such a way that also it has reactivity. It can control or it can balance the other performance, whether flexibility or outdoor durability and all these things. Few of the products like 1227, these are mainly medium solid, ultra fast use, whereas for FC 9225 and 9222, these are mainly the best in class products what we have in our range. And along with the productivity, it also gives the advantage like it is, pot life and even longer uses, even after the mixing. If we see the NCO conversion rate, this also supports the concept that it is really faster than the standard fast cure products. The initial conversion happens much faster than the standard products as well as the high solid products. SCA resins, this is a sag control resin, sag control additives that has been used for these vertical areas, portions to control the sagging defects in the automotive. So we have these products which are based in some urea-based chemistry, which are the crystals being used in the polymeric systems. And in that segment, we have different strong SCA. These are mainly opaque type in nature. But when you heat it, it slowly, become transparent. So for this case of oven baking systems for the metals and all, we can need this type of strong SCA products. So Cetalux 61767 like and 61 series, in 6 series, these are the strong SCA products. But for plastic, what is the solution? Because you cannot heat up to 120 degree, 130 degree. So in that case, we have the transparent SCA. So the beginning itself, it is very transparent. You can use in your formulation and it does not generate any kinds of opaqueness, haze in your clear coat, top clear coat. So all gives a nice balance in the flow, leveling as well as the sagging at the time of flash off and in the oven. The opaque SCA is also, it also generally works in the, as I said, in the 9 SCA, sorry, the light SCA is the very small particles which need very shorter oven line. These are mainly the 7 series products, mainly the TSA and auto clear coat, it has been recommended. Transparent SCA is also 8 series, either from the beginning it is transparent and mainly meant to the small cases. Some of the niche applications, so Waterborne road marking print, they are also the Express Line 88. This is another Waterborne acrylic system that we are promoting. It has very good dirt pickup resistance and is early wash water resistance. And it also have hot tire and mar resistance. Mainly used for the airport and other road highways. Secondly, the roof tile coating, UC Krill B3033, 3046. These are the products. It has a better efflorescence resistance as well as high weather resistance because it's been used for the roofing, so you need to have a very high outdoor performance. Thirdly, the parquet flooring, the Dex 10, mainly the urethane based product, the PU F125, Residol SF8010 and 8011. These are the hybrid type chemistry, as I said already. It is oil modified acrylics. Setacua first one is used mainly for the clear coats. These are the PUD type, which is having free from the surfactants as well as the amines free. So mainly used for excellent flexibility and impact resistance. Whereas this Residol series, they are mainly used for the stain kinds of product. Lastly, the PU flooring, this is also an advantage top on the epoxy system. These are excellent clear films is built up after the application, and because you are moving out from the epoxy, you have the advantage that is a BPF free and there is no chance of leaching and fumes of the epoxies, which brings along with the chemistry. So here this chance is not there. We can be used for the storage of the foods and other items, or even for the pharma warehouses. But these have the definite advantage. You need top on the epoxy, and where epoxy cannot be used. And these are also can be used for all the temperature seasons, like negative to high temperature of around 70 to 80 degree condition. These products can withstand all this thermal shock resistance. So we are all present in all these segments, whether it's a deco, whether industrial, packaging, automotive and all. So what we need to work together, hand on hand, and so that we can bring all those products into the market and bring definite, innovations, real innovations, what demands the brand owners or the manufacturers. Thank you all. Thank you for your attention.
Check. Anybody from the audience, if you have any kind of questions or corrections, the stage is open for everybody. You can raise your hand and we will pass the mic to you.
Hi. Thanks, Mr. Chattopadhyay, for very nice insights about the emerging technologies in industrial resins. I just want to know, when you say about UV 3D printing, so you had a brief about the epoxy acrylic system. So do you have any study for silicone chemistry as well? Because the trend is towards silicone for industrial, high industrial applications. So
for silicone, I don't think we have that study. Yes, we don't have.
Okay, yeah, thanks.
Because mainly we are into silicone, we are doing in certain segments in UV, mostly it is focused on the additive kind of applications. Okay. So not primarily on the major portion of it, formulation, yeah.
Okay, thanks.
All right, Mr. Chattopadhyay is still here. Anybody, if you want to ask a question, you just have to raise your hand up.
Chattopadhyay, very nice lecture.
Thank you, sir.
The Allnex has been all growing for last several years, from IG Farben to Hex to Bayer Technologies, and now in headquarters Germany, and it's very nice. Yeah. Secondly, you replied nicely about the silicone. Silicone is an additive part, so you are in the main function. But about your slides, I think slide number 3, 4, 5 maybe, when you talk about UV A, B, C and V,
yeah.
When we talk about short, medium and high wavelength of, because if you see IR is 800 above, visible is 400 to 800, and the UV A, B, C and V is between 200 and 400 nanometer phenomena.
Correct.
In one of your slide, as a common sense, the correction would be the shorter wavelength penetrates more. Short.
I mean, you say like UBA. UBA is generally the longer wavelength.
Yeah, whenever it is a longer wavelength, the penetration of insight into the substrate is, restricted because it's of bulkier nature. When A, B, and C and V are discussed.
Yeah, I think, sorry for interrupting you.
Yeah.
I mean, if you go, maybe the
it's okay.
third or fourth slides, what you wanted to capture there,
Yeah.
I mean, top on the substrate, if you see the layer thickness.
Yeah,
And we
thickness.
tried only just to show how much the penetration on the liquid layer, not on the substrate. So the fast higher wavelength is reaches to the bottom of the liquid layer so that it gives a better adhesion, intercoat adhesion with the substrate.
Below the surface and the film, the lowest portion, bottom portion, is cross-linked with the shorter wavelength.
I mean, in general, UV, what we say, I mean, it's not
Surface
the
cure.
surface cure happens with a shorter wavelength because it only reaches on the surface.
Correct.
Yes.
So when we talk about this, and in this situation, whenever there is an initiator, because it's shorter molecular weight material, so you have SN1 and SN2 reactions when you have an amine related and you have non-amine related.
Perfect, yeah.
So what happens when we talk about UV A, B, C technologies, generally these are getting into the murkier and muddier radar because of the leakage and the spillage, or rather the exudation, or rather the migration of these toxic CMR labeled material.
Yes.
So that's why we talk about EB. So do you have, you said the initiator which is molecular weight high.
Polymeric photoinitiators we have.
But do they cure all across A, B and C?
Yes, and to support more, that's why we have introduced another two grades which are cross-linkable oligomers. If you remember the LED Leo 101, 103, these are the products to complement these photoinitiators reactivity.
They go outside the purview of UV acrylic because they are cross-linkable, self-cross-linkable.
Yes.
So they don't need in any way these things.
But still, you cannot balance that react productivity, what you want in your line. So if you only go for the polymeric photoinitiators, you are of course right to some extent, that we cannot match the reactivity. Whereas if we introduce these kinds of self-curing oligomers, it will balance both the productivity as well as the overall reactivity, and the oxygen inhibition also you can manage.
So you step out from the UV and EB beyond. When it comes to this, a blend, hybrid.
Yes.
Okay, we'll continue. Thank you.
Thank you, sir.
Thank you so much for the brief discussion over the topic, and with that, everybody, now I would request Mr. Bhagesh Narkede once again on the stage to felicitate our speaker with a token of appreciation. Everybody, let's put our hands together for Mr. Supratim Chattopadhyay. And taking this opportunity to announce us that after each speaker's session, we are going to have some followed by question and answers round. So feel free and raise your hand up if you have any doubt, any queries or any questions. Our speakers would be more than happy to answer you back. For now, I will request Mr. Gaurav Satya to proceed and accompany our next speakers over the desk. Please welcome from Tipco Engineering. They are going to speak up on the topic Turnkey Solutions for Resin Industry. With us are Mr. Prince Jain and Mr. Anup Kumar Singh. I'll request Gaurav sir to hand over this beautiful planters to both our speakers. Mr. Prince Jain, a seasoned professional with 8 years of experience in sales and project management within the chemical industry. Graduated in bachelor's degree in chemical technology from SRM University. Demonstrated expertise in handling critical applications, managing products across diverse sectors, and optimizing chemical processes to enhance efficiency and performance. On another side, we have Mr. Anup Kumar Singh. He is a business head, and Mr. Anup Kumar Singh is a B.Tech and MBA graduate. He is a seasoned business leader with over 16 years of experience in sales and business development. Handing over this dice to both the speakers over here, and I hope you all will enjoy and learn a lot from the speakers.
Good morning, esteemed delegates, guests, and members of Irma. First of all, I would like to thank Irma for giving us opportunity to present here in front of you, to present here our presentation. Our presentation. Okay. So today we will be giving a brief introduction about our products, what Tipco Engineering does, and then what is the like new products that we have developed. Okay, and the product range that we have, and then turnkey projects, turnkey solutions, what we can give for resin industries. Okay, so basically Tipco Engineering, it was established in the year 1985. Currently we have around 40 years of experience in various industries like resin, paints, inks, and various other specialty chemicals industries. So we provide solutions for mixing, milling, homogenization, turnkey solutions, for many chemical industries. Our product range includes like high-speed dispersers, swing shaft dispersers, mixing tanks, blenders, reactors, SS reactors. Then we have, PB structure also we do, G1, G2, mezzanine flooring, piping, filling stations, and many other products. So currently we handle from raw material handling to final packaging, all the range of products required to run a plant. Okay. So for making high-end machineries, we need machinery to make precise parts of the machinery. So we have incorporated almost 6 new CNC machineries, VMCs, and then laser cutting machines imported from various other countries, and then we have polishing machines, and a few machines has been added over the last few years. Okay. So currently we are coming up with a new 5-acre facility in Sonipat, and one lab trial unit facility in Pune, where we can do trials. A customer can come to our lab in Pune and they can do trials for their products. It could be any paint, ink, resin, formulation. They want to try something new at our Pune facility. Okay. For engineering, for different products, we have different MOC as well, like the material of construction. Like in high-speed dispersers, we have SS, and then in SS we can do 304, 316, 316L, and then Hastelloy also. And then we can have different material of constructions for different parts in tungsten carbide or SS. Currently we have ISO certification, as well as in international market we are giving CE certification also for all our range of products. Okay. So these are some of our customers, like 3-bond, Epoxy, Set, Sabu, Berger, Sakata Inks, Kansai Nerolac, Hutamaki, Westech, NFL, mostly into paints, inks, and resin industries. A few more in the same industry. So currently we are catering these industries which are like resin, paints, inks, coatings, construction chemicals, and many other chemical industries. Okay. So regarding the equipments, we have high-speed dispersers, mixing tanks, a wide range, hydraulic if you want, or platform mounted, suspended. We can do all range of products. In the mill series, we have basket mills, horizontal bead mills, vertical bead mills, attriters, batch type bead mills. All these we do have. and the laboratory models for all the products that I have mentioned earlier. And then in recent developments, we have developed homogenizers, high shear homogenizers. There are two types, basically a high pressure homogenizer and then high shear homogenizer. We have developed high shear homogenizers for both in-tank type, bottom type, inline type, and there is one series called Super Series. So in Super Series, this is basically the inline homogenizer with a very high tip speed. So this is our high-speed dispersers. The picture shown here is the one with hydraulic design. So we have different types of cowl design as well for different applications we can serve. Also, for different applications, we can have a different diameter of the cowl or a different tip speed we can work on, and then the material of construction for the cowl as well. In the mixing series, we also have some different configurations, like with scrapper we can give, with butterfly, with some pitch blade design, and many other designs we can give. So high-speed dispersers we make from laboratory model, like starting from a range from 1 HP to we can go up to 300 HP, like platform mounted, hydraulic as well as suspended. So in high-speed dispersers, this is one of our implementation in South Africa, where the customer wanted three high-speed dispersers which can operate for 3 tanks. So this particular high-speed disperser will go up and it can be operated in 180-degree directions. All 3 tanks it can serve, and from the person at the bottom of the platform can fill manually, or it can be done semi-automatic or fully automatic filling also. We also do vacuum-based high-speed dispersers or twin shaft dispersers. Then we have homogenizer series, as I mentioned. We have in-tank type, inline type, bottom type, and then the super series type. Then this liquid powder mixers we use generally where we want to mix some solids into liquids, generally in paints and ink industries, where the solid content is below 60%. We can use liquid powder mixers. It basically enhances the dispersion rate for your paint or inks, and it gives better efficiency in terms of your energy savings, as well as production time is less. So in homogenizer, we have different types of stator heads available with us. One is slotted type, emulsion type. Then we have different types of rotor heads also. Okay. In horizontal bead mills, we have different types of mechanical seals. In mechanical seals, if we talk about there are mainly 3 types. For the double cartridge type mechanical seal, double mechanical seal, that is like in SS304 we can have silicon carbide rings. Then we can have elastomers like Calrays, as well as Teflon, or maybe any other elastomer as per the requirement of the product. Then we can have ceramic mechanical seals also. Okay. Then in material of construction, as I mentioned, we can give SS304, 316. Then we can give silicon carbide for low contamination. Then we also have mills with gap separator and screen, both design we have. Then in pumps, we can give you solutions for different applications like AODD pumps, air operated double diaphragm pumps, then gear pumps, internal gear pumps, external gear pumps, piston time pumps, and screw pumps, all types we have. Then after sales service, we have a very good sales service team sitting in Pune as well as Delhi. So this is our horizontal mill series. Recently we have made a few changes in the design for better efficiency and optimization. So this THD series, we call it like the screen series, we call it THD series or TSC series. In basically the difference between THM, like the gap separator series and the screen series is the productivity. If you want better productivity or the viscosity of the product also decides whether you can use gap separator type machine or your screen type machine. Then we have this basket mills for batch type of grinding. In construction chemicals, we are doing for various products like admixtures, putty, concrete related compounds, epoxy grouts and other products. Okay. So this is one of the putty plant layouts. As you can see, we have different types of solvent conveying system, then the mixer, fluff shear mixers, then it goes to your conveyors, then it goes to your packing machine. So for epoxy grouts, we can have sigma mixers, and extruder is mounted on the bottom of the sigma mixer, as you can see in the picture, and it can take out your product, very high viscous products ranging like 3 to 5 lakh CPS viscosity also. Then the lab models for all the products we have, as mentioned in the slides. These are some of our projects that we have completed. We have completed around 30 plus turnkey projects in India and abroad. Some of our clients are like JK Max Paints in Bhiwadi, Aditya Birla Ultratech Cement. We have completed their water-based paints plant. Okay. Normet Austria, Sirka Paints. Then we have Sunlac Paints and many others are there. Now my colleague Mr. Anup will take it further.
Thank you, Prince. And thank you, Irma, for providing us such an opportunity to share our key strength. So as far as turnkey is concerned, we all know turnkey starts, sorry. Yeah, thank you, sir. So turnkey, when we say turnkey, so it is showing this complete plant where you could start from raw material storage to transfer to power supply to PEB structure to complete agitation system, then final filling. So right from upstream to downstream, we have covered in this. Sorry. So this is the complete scope where we have covered a turnkey can possess, starting from design, engineering and consultancy, total plant automation, Tipco process machineries. We are already in one, like my colleague has already covered all the product range which we cater to across the industry, right from paint, ink, resin, and other construction chemical and specialty chemical industries, where our name is one of the reputed vendor. We have already established that. Going forward, we are focusing more on bringing one-stop solution. So this is where our name is, like he has mentioned, 30 odd projects we have already executed in many these segments, starting from resin, paint, ink, and construction chemical. PV designing also we can do. Design and supply process equipments, that is already we are established. Auto powder unloading or transferring. Process design, pipeline execution with automation, valves and other things. Total structure, layout of the equipments. If you require any certification, we can also provide that. P&ID and process layout usually come from the customer side. Filling and packing machine, liquid process system, manual or automation. All third-party items, chillers, compressor, cooling towers, this we can source and supply you our complete solution. Design and suggestion suitable pump as per the process requirement. Process instrumentation, load cell design, supply and calibration, all electrical. These are peripheral items which a turnkey project does require. So we do provide along with our whole system. RO, ATP design, all safety measures. This we cover in our turnkey. Coming back to our key area, resin. As we all know, we are discussing since morning, resin is a very happening area. We have a market size of say 25,000 crores. So this is a big market. And we have employed ample number of manpower in this, direct or indirect. And coming back to our area, like we all wanted to make this particular business sustainable. So bringing sustainability without bringing automation to the industry, it is near impossible. So we have to be globally positioned well. If we can have EcoVadis certification, we can have Industry 4.0 incorporated systems. So this is where we want to bring Tipco as a partner who could provide you to meet the sustainability requirements. Acrylic resin, alkyd resin, epoxy resin, and polyethylene resin. These are the key areas where we have already executed some projects. So these are the key area where you require some sort of discussion as far as process is concerned. Polymerization usually happens, so that reaction needs to be controlled, and that to bring it control environment, you require right reactor designing. So those are the area where we come into place, and we bring right designing as far as ASME standards are concerned. Distillation. Sometimes you require distillation, sometimes you require recovery of your solvent to reuse that solvent. That also we do provide. Impeller selection is also a key area. If you give high agitation, your reaction may lead to some big damages. So there we also come into place. We bring right calculation for your reactor design. Variable frequency drive to give you the right power to your mix. Every time we do discuss that these are the reactors being used, but have you think to optimize it further? Because this is the area where we can bring some sustainability in terms of efficiency. Heating and cooling systems, which is also play a very important role to streamline your reactions. Temperature sensors, which gives you right temperature at right time. Otherwise, it lead to a big damages. And automation, to get your all data right. These are the typical pictorial diagram just to showcase and some installation where you can understand what sort of system we have supplied already. These all are executed project design. Alkyd resin reactors, which requires reaction with certain cooling arrangement, right in internal coil, right in external coil, so that you could get better surface area to have right cooling. So this sort of design we have already done for some of the company, where we have also added some condenser to re-condensate your part of solvents and reuse it. So these are the typical resin equipments requirement for a turnkey projects. So raw material storage tanks, silos and powder conveying system, liquid transfer system, process reactors, distillation column and filtration system, blenders, finished goods tank to store your final goods, pumps, valves, piping design, control automation, and filling and packing area, retail and bulk, depending on the need, and palletization and racking. These are the key elements required to have a turnkey solution. These are again utilities we require: generator, transformer, cooling tower, water tank, thermic fluid boiler, nitrogen station, pumps and pipeline for liquid and nitrogen transfer, boiler fuel tank farm, electric control or automation, fire hydrant systems, effluent treatment plant, and wave bridge. These are the typical requirement for a turnkey solutions. You could see here 2D as well as 3D diagram which we have captured just to showcase. In the center you could see the mixing reactors. At the upper section you could see silos where you can store all your raw materials. So RM can be stored somewhere in that tanks, then transfer it to the mixing zone. So this might be coming into G+2 kind of a structure. So we have just shown here G+1. Some sections are at the topper end. These are the typical layout for an alkyd resins manufacturing process where polymerization happens. These are storage tanks which we require for storage of our raw materials and then transferring it to the mixing zone. These are the storage tanks. You can also put on load cell so that you can have the data, what all storage you have. These are the powder transfer system. So both way, either is screw transfer or you can do pneumatic transfer or vacuum transfer, depending on the requirements. We can propose that. These are again powder transfer system. So these all are executed project. Some of the pictures we have covered it from paint. These are liquid automation. Once the various liquid additive or different liquid can be charged and transferred it through different piping. These are filling. One of the good area we are also into pigging system. Pigging system industry might not be knowing. Petrochemical is the area where these are these are in regular use. So this is also one thing can be bring into this industry. If you want to clean a pipe from internal way, so this is the one way you can do that. You can put inside one transmitter, one receiver, and you can clean your pipe with certain good pressure. So this can be calibrated based on your need. Sizes of the pipe and something can be given from the process, customer side, and then we can propose the design. So these are the typical designs which goes to. ETP-RO is also something, company asks for a zero discharge system, so we can make that. With the help of some third party, like we have some partners who do provide this kind of systems. Storage of additive tanks. MCC panel and control panel. So are the total electrical system we can provide. So these all are in-house capability. So other than resin, we are also one of the leading player providing solutions to paint and ink. So this is something which we have already executed. So per day they are producing 108 KL. So this is a good number. We were not disclosing the company name, but if required in person, we can discuss that. These all are process and utilities we have already designed for some of the company which is running right now. Solvent-based paint also we have executed. So that also requires, these are the things. So this kind of turnkey project we were doing regularly. 30 plus projects we have executed so far. And at present also we were doing at least 10 such projects. Plant automation designing, we can also do that. Other than our this regular selling of our equipments. PNID, process flow, those things also we can work it out along with the customers. These are the typical layout for a solvent-based paint plant. This is an ink plant which we have executed somewhere in Gujarat. Plant automation is one very, very strong area where people are now thinking to have their whole system automized. So we are providing, along with automation, SCADA and everything, so that plant can be automized and meet the global requirements. So what exactly the benefit we are going to get with automation? So manpower is definitely going to reduce drastically, and consistency of product that we all are looking at. So higher production, low wastage, saving energy, complete traceability of your product or production, stock management and safety. These are the key elements for any company who are looking for automation. These are the actual photo which we have executed somewhere. So batch card, how they make a batch card. So you'll get a fair idea about. These are the filling machine. These are again a resin plant which we have executed in Haryana. So they have 2 10 kL tank with all condenser and other thing. Charging some parts they charge manually, some parts they do automation. And then the material dispensing. Thank you. We are looking forward for your questions, sir.
Check, test. All right, so we have
Thank you, sir.
the open forum for questions if anybody wants to ask. All right.
It seems we are at lunchtime. Okay, thank you.
All right, so I think our speakers were very clear at their presentation. There are no doubts or questions as of now. We are proceeding ahead with requesting once again Mr. Gaurav Satya over the stage, and I would request Satya sir to proceed with token of appreciation towards our speakers, Mr. Prince Jain and Mr. Anup Kumar Singh.
Make it one by one.
And with that, we would like to proceed our thanks to Tipco Engineering for Prince Jain and Anup Kumar Singh. Once again, thank you so much to Mr. Prince Jain and Mr. Anup Kumar Singh for joining us up over here. And with that, as rightly guessed by Mr. Anup Kumar Singh, it is the lunch time. So we are going to proceed towards a short and sweet lunch. I hope you all will enjoy, and the next sessions over here are going to be much more interesting because we are going to have a motivational speaker motivating all of us. So for now, let's get motivated towards the lunch counters, and afterwards we are going to have some more knowledgeable sessions over here. All right, and with that, we are going to head ahead towards the most difficult session in this entire world. After lunch sessions are very difficult, especially when it comes to knowledgeable and technical sessions. But we are so happy that our next speaker is not only a knowledgeable person, but a very, very good orator. So, ladies and gentlemen, let's proceed ahead and welcome on the stage BASF Corporation से जो खास तौर पर हमारे साथ यहाँ पर जुड़े हैं. And the topic over here for him is innovative acrylic emulsion technology enabling matte coating without mating agents. And to bring the speaker over the stage, I will request Mr. Rajendra. Mr. Rajendra, please accompany our speaker, Mr. Sendil Kumar Rangasamy. Let's put our hands together for Sendil Kumar Rangasamy coming over the stage, and I will request Mr. Narkhede to hand over this beautiful planter to our speaker. Dr. Sendil Kumar is a global application technology manager at BASF's North American Industrial Coating Group. His current role focuses on developing acrylic-based polymers and coating for the wood and metal substrate. With over 14 years of industrial research experience in the synthetic and formulation of acrylic emulsions, polyurethane dispersion, and silicon and UV curable resin, primarily for CASE applications across aerospace, aeromotives, and general industrial sectors. Over to you, sir.
Good afternoon, everyone. Thank you for your time. After lunch, we are meeting. I hope I won't make you sleep. That's what my boss, Selva, told me. Then he doesn't realize that I should not sleep before that. So let me start my session. I'm sorry. Can you have the other mic? So at BASF, we create chemistry that creates next generation technology. So this time we created a technology using chemistry that is expected in the coating industry for a very long time to develop a coatings, particularly matte coating, low gloss type of coatings, without adding any type of matting agents. So before getting to the topic, I would like to introduce our portfolio. I'm not going to talk about the entire BASF portfolio because the 30 minutes time is not enough for us for that. So I'm going to just talk about the industrial coating section of this portfolio. So we do have various type of polymers, whether it can be 1K system or 2K system or 100% solid system. We can offer materials for a water-based system, solvent-based system, as well as energy curable system. When it's come to sustainable energy, we are working so hard that by 2050, whatever products that we are making at BASF, it will be negative zero carbon dioxide produced. Whether we are producing it or whether we are manufacturing it, the energy used and the outcome, everything will be zero carbon dioxide, which means we are also working on capturing some of the carbon dioxide and using that energy to convert it in the manufacturing facility. Now, as I mentioned, we do have a various technology. Since it's a water-based one, I'm going to talk about the wood coating. So when it's come to wood coating, we have, for sandability, we have Jonquill 8181. And for fast drying and sandability, we have 8111. And then if you want to have a block resistance after applying the coating immediately, if you want to use it by blocking in the production facility, we do have 8224 that offers really good blocking resistance. And then for excellent water resistance properties, I would suggest to use the 8330, which not only for the wood, it can also applied for metal substrate as well as the plastics. And in a plastic itself, either engineering plastic or the commodity plastic, you can use it. And the next one is it's a recently launched material, Jonquill 9503. The technology that we used over here is like when you see the conventional polymer, when it dries, it may create some type of voids in the film, even though it doesn't look, you cannot observe it with the naked eye. When you see it in a SEM image, you can clearly see that. And because of that voids, you may have bad stain resistance. Here, when I say the stain resistance, stain because of wine, coffee, or mustard, those kind of things. And how about the staining the wood? For that, we do have a colloidal chemistry, which is based on a Jonkel 95 CN. If you can see the image comparing to the commercially available material and our Jonkel 95, the depth of the stain will be long, deep for our material. That being said, since it's a wood, always there is a problem with tannin. For that, our solution is Jonkel 8227. We also offer hybrid materials. Some of our customers are asking, why don't we simply blend the PUDs and acrylic emulsion? You can do that, but if you see the durability side, after making the material after 1 year or so, you may not get the same properties that you can get the day one that you made that material. So that's why we have hybrid type of materials also in our solution, in our portfolio, which has both acrylic and PU backbone in its polymeric chain. And then for high glass, we have 2K PU. It can give you the glass values like a solvent-based one, which is Jonkel OH 8710. With that, I would like to enter the current projects that we have been working based on the current market demand. How about the sound insulation? This is one of the hot topic nowadays after pandemic. Most of the people started working in work from home. So always there will be kids playing or some other activities. So whoever working from home, they have to have this insulation in their office, home office. So some of the builders in US, they started making coatings or the insulation pads just for that particular room so that they can insulate the sound effectively. Technology was used previously in the cars. If you can see, the car, some cars may have really good, after closing all the windows and the door, you may not hear anything at all while driving. So that is because they have, that type of car has really effective sound insulation system installed in it. So with this, I would like to introduce one of our current one. This is still a scale-up stage. That's why there is no name. This is a Jonkel material again. Currently, customers are using multiple emulsion because based on the temperature, the insulation properties may vary. But we come up with the solution where you can use just one emulsion. You don't have to use multiple emulsion at the production facility. You can use just one emulsion and you can achieve all those dampening effect. You can see that the second one where we are saying from 0 degrees Celsius to 60 degrees Celsius, the target is currently at the industry is like a 0.1 vibration composite loss factor. We can achieve more than that, up to 0.24 with this polymer. And then when it's come to the energy curable system, we have an answer for ongoing demand of battery insulation application. As you know, nowadays most of the industries are still using a PET type of film, but the energy demand is like the EV car should go longer, more than 500 miles or 400 miles like that. And also the durability should be like how long you can charge your battery. Can I do it like at 10,000 cycles, 5,000 cycles? Based on that, it extends the battery's lifetime also. Instead of if you have to change battery every 2 years, with this, let's say you may be changing it every 6 years or 7 years. The demand is only one way that we can do that is like if you have a dielectric breakdown strength more than 5,000 volts. So with our UV curable system, we got our Laromer resins where it can go up to 9 kilowatts. So which is like a more than the current demand in the market. This is like a not based on the film, it's just a UV curable coatings. You are applying it and exposing it to the energy so that it can insulate the battery pads effectively. So what happens if it is exceeding that 500 limit? That's when the PET films fails and vehicles start catching fire and everything. So these type of resins, it will allow you to increase the breakdown voltage more than 5,000 volts. We do have some monomers also that can help you to even increase the resistivity, volume resistivity also in this case. And now let's get into the matte topic. Right now we are working to help some solvent-based customers also. For that our answer is we do have some dispersing agent. This is an scale-up stage, that's why we do not have the number, but the lab number CGPS 278, 242, that's an answer for that. If you use this type of dispersing agent, it's sooner to be launched this one. You don't have to worry about the amount of, sometimes when you increase the matting agent in your system, it may increase the viscosity. And also the matting agent may settle after some time. So that's the result. The benchmark one, you can see the gluey material. I'm not sure the people from the behind can see it clearly, But when you scoop it out with the, this thing spatula, you can see it's a gluey, chunky that aerosol particles or silica particles, I can say. With the BASF dispersing agent, you won't have any of those kind of problems, and also it controls the viscosity better than existing materials. Now, let's come to my current topic, which is innovative acrylic emulsion technology enabling matte coating without adding any type of matting agent. Once again, this is for water-based system. So what, like I said, the goal is we have to have a natural looking appearance in home. We should not have like a high glass kind of thing, otherwise the reflection may hurt your eyes. So main reason is like to provide you natural looking environment inside your house itself when you use a wood type of substrates. So how light reflects when it's come to high glass and low glass substrate. When the light hits the high glass substrate, it simply specular reflection it happens, which means the surface is smooth and it just reflects that light. That's why you are ended up having high glass side. When it's come to matte coating, you can expect a diffusive reflection. Why? Because the matte polymer has some micro roughness on it, this coating. You won't observe it even when you touch it. You can get that image only with the AFM instrument. So now, this is the typical formula. Coating some manufacturers may be using it by adding some matting agent in the system. So matting agent is, most of the time it's an inorganic material. When you add it with the organic material, when the film forms, the film shrink, but the matting agent won't shrink. That's why it's creating a micro rough surface, and because of that, we are getting that diffusive reflection when light hits, and we are getting low glass value. So what's the problem with this? The problem is, when you use matting agent in your system, you can expect poor chemical resistance, water resistance. Even the durability also loses. Why? Because we are trying to combine inorganic and organic together. So when you do that, there will be always some micro phase separation between the polymer chains as well as the inorganic particles. So that's what affecting your durability of the coating. In our case, we are not going to do anything like that. Now let's get to the point. Why matting agents are more than sometimes 10 micron? What is the reason for that? So the main reason is, if you see the visible light spectrum, it's like a 400 nanometer to 700 nanometer for the human eyes. So anything less than 400, you can expect high glass values. If you can get the particle size more than 700 nanometer, which means you can expect low and low glass. So that's why here we are also making micron size particles. Now, this is how emulsion film forms. It has 3 different stages, because emulsions are nothing but particles. You are mixing oil in the presence of surfactant and dispersing it in a water. So those are all like a different particle size. When you apply it on a panel, when you cure it, it has 3 different stages. Like I mentioned, first stage, about 70 to 70% or 75% of the water evaporates, and all those particles come close together, and the particle ordering can happen. And the second stage, those particles, whatever came close together, further water evaporates, so they will deform. So the spear-shaped particle become a hexagon-shaped particle. And then when it further evaporates all the water, that's when the polymer chain interdiffusion happens between one polymer particle to the another polymer particle. And that's how film is forming in acrylic emulsion stage. So what we did here is, this is the typical one. Any emulsions behave like this. But we want to utilize, we wanted to introduce some self-stratification, which means like a smart self-stratification here. The way particle ordering is happening and the way polymer chain interdiffusion is happening. That's what we influenced in our new polymer. So how did we do that? First, when it's come to the particle size, we didn't rely on uniform particle size. We made it gradient particle size. All those are micron size. And then second, when it's come to the polymer chains, we made it gradient molecular weight polymer chains. Gradient hydrophobic to hydrophilic polymeric chain and gradient TG polymeric chains also. These are all in one system, not multiple polymers mixed in it. And now how this will happen. So when large particle and small particles mix together, most of the time we will think like all the particles are going to come and coalesce. That's how film is forming. Remember, this is not a UV technology or solvent based one. Here the particle ordering will happen based on the size of the particle. So which means the larger particle first coalesce and then goes to the next size particle and then next size particle. That's how we are creating our stage 1. And this happens before particle rupture happens. And once particle ruptures happens, then we are introducing all those high molecular weight to low molecular weight polymeric chains, and then they interdiffuse with each other. They will stratify further so that you can have really good scratch resistance, chemical resistance, along with low gloss properties. And this is how the polymeric chain stratification can happen. If you have a long chain molecular weight, which means high molecular weight polymers, they simply stay in the same, even during interdiffusion stage, they may be staying in the same particle. But when it's come to the low molecular weight, depending on the TG of the system and curing condition, either it can stay in the same particle or it can diffuse from one particle to another particle. Same goes to the different polymeric chain hydrophobicity also. Based on the TG, hydrophobic polymeric chain, they tend to go to the surface of the coating, and then hydrophilics, they tend to go in the subsurface of the coating. So because at the hydrophobic chains, as you know, they hate water. That's why they want to escape from the water system. They ended up having the top of the coating. That is good for us because with the hydrophilic, you can achieve really high bond strength. And with hydrophobic, you can achieve really good chemical resistance and water resistance properties. And remember, like I said, this is not a UV system where all the things are happening like that. This is a 3-stage polymer. Slowly, based on the temperature, the films of particles are coalescing, which means all 3 stages, stage 3, stage 2, stage 1, all are at the same time. You can expect that. A polymer film forms from top to the bottom of the coating surface, and at the top, when the skin forms, still under the skin, you can have your stage 2, where polymer is still coalescing, and stage 1 beneath that, where still more amount of water is there. And through the diffusion, all those waters will be escaping, and then you will get the continuous film. This is also helping us to achieve low gloss with excellent chemical resistant properties. Like I said, this is a gradient particle. This is how we made it. It's not a uniform particle size. It's a multi-mode particle size distribution. As you can see from the different peaks, it's not dual mode also. Many of the researchers out there, they are working on dual mode. We already passed that, and we are making multi-mode particle size. This is the standard formulation, starting point formulation. As you can see, we didn't put any type of matting agent in it. Obviously, we added some amount of dispersing agents and some slip agents, all those things, wetting agent. But other than that, you won't see any type of matting agent that is required to achieve low gloss values. At wet stage, in a can, the polymer will be milky white. So it won't be like a transparent anything, because it's particle size effect. These are large particle, that's how it looks. But once it dries, we made it like a zero, our image you can see, it's milky white, and the same BASF logo you can see after 7 days of curing, it's 5 millimeter film thickness, not just 1 millimeter. It's still, you can see clear transparent effect, which means the matte effect that we are getting, it's not because of haziness. Transparency is there, more than 95% transparency. Next, this is the cross-sectional image of the coating after drying it 7 days. You can see AFM image. It clearly shows the micro roughness on the coating, and we applied it coating on a Lanetta, and you can see the glass values in the table, 20 degree, 60 degree, and 85 degree angle. So we are targeting 60. The reason is at 10. You can achieve more than that also with the polymers, but in this case, we chose to have 10 so that we can also achieve some other coating properties. How about comparing with the high gloss polymer and the matte polymer itself? When you blend it with the high gloss polymer, when you blend with the matting agent, this is how it looks. The middle one is the milky white one, that's the inherent matte polymer. Other two are like we used both inorganic as well as organic matting agent. And you can see the black color panel other side. I'm sorry, I do not have a laser, so I can just talk. The high gloss 1 and 2, you can see it's like a whitish appearance is there. That is because of the matting matting agent. Whereas inherent matte polymer, the clarity is better than the high gloss one. And that's when you can see when it's come to the water whitening or ethanol resistance, you can see better with the inherent matte polymer. It's not affecting the coating film at all. Not only that, the way the film is formed here, again, you can see bars were used, and you can see the blue lines here, both the side. Whereas with the matte polymer, you won't see that anything like that. Why? Because we are controlling the viscosity. There is no matting agent, which means you don't have to worry about the viscosity, which means you can, if you want, you can make high solids coating, and if there is any requirement for VOCs, you can achieve with this polymer easily. These are the chemical resistance. We did most of the standard chemical resistance used in a market or household: vinegar, ketchup, mustard, red wine, and coffee. Obviously with some ethanol and IPA also. They were directly applied it on a wood coating, and then we measured it after 1 hour, how the 5 is the best numbers and 1 is the worst number. The pendulum hardness, all those things are regular coating people will be looking for those kind of opportunity. I want to point out the nano scratch resistance. It's 5.74 nano scratch. We are not using pencil hardness because pencil hardness usually, depending on, it's a subjective analysis. One chemist may get different result, another chemist may get different result. That's why we relied on a nano scratch instrument. Almost 6 Newton here we are achieving with our starting point formulation itself. How? Because we are having that self-stratification effect in the system. That's why we are getting really good film forming and effective hardness in the film also. Next one, this is the most interesting data. When you have a high gloss polymer and make it as a low gloss material by adding matting agent, it may not last longer. The longer you touch that surface, for example, burnish resistance, in this case we use the scrub instrument. You can see after 200 cycle, the glass is increasing. In order to achieve the same glass value comparing to the inherent matte, we added about 5% of the silica matting agent in this formulation so that we can achieve almost similar glass values at a 60-degree angle. But after 200 cycles, you can see the glass is increasing in the high gloss polymer. Why? Because we are rubbing off all those matting agent, which means your high gloss polymer is losing all those matting agent. Because of that, you ended up having high gloss. About 70-80% of the increase you can see. Whereas with the matte polymer, it's hard to notice where you tested your substrate. So only 0.4 degree difference at a 60-degree angle comparing to the initial and final reading. You won't even notice like any scratch is happening or any burnish, any type of mar also in this film. So what if you want to use it in a as a co-binder instead of using a standalone material? Most of the time, if you want to have like a low gloss or a mid gloss range, people may still add some matting agent. In that case, you can use this acrylic emulsion. Based on the amount of emulsion added, you can reduce your glass values also. This chart shows that. And again, by using this material, you will achieve excellent burnish resistant properties. Same goes to the PUDs also. It has excellent compatibility with PUD, and the results are same. And the application can be used for both sports floor, like a basketball court, or our indoor application also. And then automotive interior also, if you want, if you want to develop some haptic type of application, you can use that. With that, I would like to conclude my session. I hope I didn't increase my time. I can take any question.
I just have one question in the last section of your presentation.
Sure.
First of all, thank you for the nice elaborative presentation. You have compared this, kind of ultra matte coating through Waterborne technology. I mean, if I just wanted to see how it behaves compare, as you are also have an experience on the ultraviolet chemistry. So if you compare this Waterborne against the Excimer, how it stands? I mean, is it better or similar, or what is your comment on that?
So Excimer technology, as you know, it's 100% a solid UV resin type of thing. Even you can use it for a solvent-based UV curable system. But this one is water-based, where you cannot use Excimer. I would not suggest that. Main reason is the advantage, if you see, you can increase the thickness with this material comparing to Excimer technology. It may have some limitation. Not only that, Excimer technology may need different type of equipments in order to create those, it's nothing but we are creating some waviness inside the coating. That's how we are achieving it. But with the Excimer technology, we haven't tested it yet. And at this stage, with this polymer, I would say it may not be right approach with the Waterborne system.
Okay. I mean, it has certain...
For now, we may be in future, we may be using it. Excimer is also our technology. Obviously, we're going to use that one also.
No, I mean, just from a selling perspective, or maybe on, performance-wise, I mean, how you can pitch it, whether Waterborne will be an added advantage or the Excimer it will be?
So, like I said, if it is Waterborne, it's all production. I have to see it in a mass production facility, okay? So, if you are using water-based, obviously we are already challenging. I believe you also notice that problem. Water has to evaporate before we do all kind of other next steps. So, that will also affect, in this case, how long you want to wait. That one problem is that I have to convince my customers to use this material. That's the main thing. I may have a cool technology, but customer's point of view, no use. That's why at this stage, from our end itself, we are not recommending this for excimer technology. Excimer is we are dealing differently. Until we have some clear understanding when we blend our water-based UV resins also, whether we can use it in a excimer or maybe if we can come up with some other new technology where we can evaporate water really fast so that you can also utilize excimer technology also.
Okay, thank you, thank you.
Dr. Ranga, one question. Nice presentation. And liked it, the advancement in emulsion technology from maybe bimodal to multimodal. But one question, whether that multimodal, since the particle size is so high, whether you are required for the final product to use a special filter or maybe a coarser filter. Otherwise, those higher particle sizes will come on the filter only.
It's an excellent question, but the filter that we are using can filter up to 125 micron. So we are not worried about that in this case, because mostly those filters will capture the grits, coagulum created in the reactor. But in this case, we are making maximum, if you see that D90 was about 7, which means I have maybe 10% of the particle in 7 micron size range. We are not facing any issue. And also it's a fast filtration, because after making this polymer, the first thing we did is we wanted to see how it filters. Because we are making thousands and thousands of gallons of
you will be
material.
supplying this to wood coating manufacturers or any other. So you will have to, when you are doing the marketing, you will have to suggest them which kind of filter to be used. Otherwise, you will lose that technology. Because if the bigger particle size are missing in the emulsion, then it will actually dry like a normal emulsion.
I agree, I agree. So the image showed
So
here.
this is a suggestion to Selva, because he is a marketing person. So he has to explain that nicely.
So the thing is, all the test data that we collected, it's after filtration, not before filtration. And like I said, we also noticed the filter. If there is any left out material, we wanted to take it and analyze that one also. In this case, whatever the left out material, they were grit, unusable materials because of the reactor fouling, all those things. So which means here it's easily passing through. It doesn't require any, I'm not familiar with the filter that we are using here, but I can say it doesn't require any special filters. The current existing technology that we have in a BASF, it produces. We tested this in 3 different locations, both Shanghai, Ludwigshafen, Germany, and US. No problem.
Any idea on what is the percentages of higher particle size, medium particle size, and lower particle size in the emulsion?
Yeah,
which you have standardized?
Yeah, that's showed, right? 1 minute. Give me a minute, please. Oh. Okay, I believe if my memory serves correct, D90 was 7 micron something, and about D. And,
that is because of higher particle size, that noise.
Yeah. Can you hear me now? Yeah. Okay. So it's like so D10 is somewhere around 1 micron, which means we want to give more and more emphasis 1 micron size particle. You don't have to have 100% of your particle, really large particle, so that you can achieve that low gloss 10 range at 60-degree angle. At certain amount is good enough for us. That's how we are varying this different range. So D10 means we have about 1 micron, like I said, and about less than 40-50% of the particles are around 3 micron range, and about 10 to 30% maybe, depending on which formula, it may be around 5 to 7 micron range particles. That's a good question. Thank you.
Yeah, thank you, Ranga.
How does the particle size, does it affect with shear? Is there any...
Good one. Thank you. I can see you are also a formulator. Yes. Awesome. As a polymer scientist as well as a coating formulator, after developing it, my first one was using this in a covers blade, high shear blade, both pigmented system and clear coat system. It's stable. That's why we are using that gradient particle morphology, not single particle size. If it is a single particle size, even the polymer itself will settle after, let's say, a couple of months or maybe 3 months. Because of the gradient particle morphology, it's allowing us to stabilize our particle even at high shear. Not only that, even when you use the spray gun, you can still get low gloss values. So it's not that spray gun is also not breaking the particles.
All right. I request Kumar sir to stay back for a while and request Mr. Raj Narkede to come upon the stage and propose a token of appreciation towards Dr. Sendil. Everybody, let's put our hands together for the most knowledgeable session over here, which was conducted by Dr. Sendil.
sorry that you feel that way. I'm sorry that you feel.
And with that, we are heading ahead towards the last technical lecture of this entire seminar. And for that, I will request Dr. Prashant Samant to come forward and accompany our next lecturer from Asian Paints with the subject Multifunctional Resin Hybrids for Coatings. Please welcome on the stage Dr. Rajiv Kumar Jain, and I request Dr. Samant to proceed with this beautiful platter to Dr. Rajiv Kumar Jain. Mr. Rajiv has been designing wide range of resins for last 39 years. He did his masters in organic chemistry from Agra University in 1985 and acquired doctorate on epoxies-based heterocyclic compounds from Harcourt Butler Technology Institute, Kanpur in 1990. Over to you, sir. This is going to be the last but not the least. The most knowledgeable session is waiting ahead with Dr. Rajiv Kumar Jain from Asian Paints.
Yeah, good afternoon to all of you. I selected today's topic on multifunctional resin hybrids actually, and this is the need of the hour, and this is the most important subject if you want to achieve the high performance coating at an optimal cost. So if we look at the trends in resins for coatings, we find there is high solids, and if we look at the high solids, we find and low VOC coatings, then we find that we waste a lot of solvents actually, and which is equally expensive than that of the solid resin. So there is no point in actually polluting the environment and spending a lot of amount on solvents. So another emerging trend, if you look at, is sustainable resins. So sustainable resins are basically derived from the bio-based monomers or their derivatives, like if you look at alkyds like glycerin, sorbitol, or oils, fatty acids. So again, this is also critical for the environment as well as for the cost. Another emerging trend, if you look at the waterborne resins. So in the morning session, we had the two lectures actually, one from Gajanan, Joshi, and another from Supratim on waterborne epoxy, as well as certain slides on the waterborne alkyds. And we got useful information, and that again works actually for the environment. Now, another one is the building new functionalities. So when we create the new functionalities or new functional attribute, that significantly improves the resin performance, and at the same time we get the lower cost. So resin hybrid is an approach actually to build new functionalities, and it also provides us enormous improvement in performance properties. What do we get actually from the polymer hybrids? So if we look, we get the synergistic effect on polymer performance, and we see all these kind of properties would improve if we make the hybrids, whether it is through monomers or through polymers. So if we look at the conventional coating resins and crosslinkers, so these are the four largest volume resins like alkyds, acrylics, polyesters, and epoxies. And these resins are used along with the respective dryers and catalysts, and certain crosslinkers like amino resins, polyisocyanates, and epoxy hardeners. So if we modify these conventional resins and make them polymer hybrids, then what kind of improvement in the performance properties we see, I'll just explain in the subsequent slides. So if you look at the alkyds hybrids, alkyds are the most prominent resin basically, which are modified with different monomers or polymers. And first one is the urethane alkyd. So if we modify with the urethane alkyd with either isophorone diisocyanates or TDI, and we get number of different kind of resins for different applications, right? From the wood finishes or for direct to metal enamels for interior as well as exterior applications. And this is not the only thing. So this hundreds of formulations can be created depending on the application requirements. And another one is the acrylated alkyd. So here the acrylated alkyd and the possible modifiers are styrene, MMA and butyl acrylate. And acrylation can happen right from 10% to up to 50%, and that can drastically improve the performance properties of an alkyd. And it finds use in actually weatherable enamels and many other applications wherein the fast drying and fast workability is the requirement. Another one is the phenolated alkyds. So we can modify the alkyds with either the pure phenolics or with rosin modified phenolics, and it significantly improves the drying properties as well as the corrosion resistance properties, and mostly it finds application in primers. Another one is the epoxidized alkyds. So again, we can use the epoxy reagents right from the liquid epoxy reagents to the epoxy reagents having medium molecular weight, and that at a stage wherein the alkyd is processed to a certain acid value, and we can get outstanding mechanical properties, drying properties and corrosion resistance. Again, for a good recoatability of the top coat, especially if we want to recoat with the polyurethane, etc., wherein we use aggressive solvents. So again, from the alkyd hybrids, we can further modify epoxidized alkyds with the urethane, and we can get further enhancement of properties, especially for the corrosion resistance performance. So alkyds, once modified either with epoxy or with the epoxy urethane, we can get corrosion resistance performance as high as around 1500 hours, which we normally get from the epoxies. Cardinol modified alkyds is another grade. Actually, I have two patents on that, that cardinol triol based and as well as using the glycidyl ether of cardinol. And wherever we use cardinol, wherever we can incorporate cardinol in whatever form, actually it tremendously increases the corrosion resistance performance. Although it takes a beating on the color, but corrosion resistance performance is amazing. Next one is the siliconized alkyd. Although it is a bit expensive, but it finds application especially for the superior weathering as well as the thermal resistance. So wherever there is a requirement of thermal resistance at low cost, the siliconized alkyds can be used. Now we come to the acrylic hybrids, and we have these two basically acrylic polysiloxane. So normal acrylic polyol we can modify with the polysiloxane with selenol functional intermediate, or else we can modify acrylic polysiloxane with right from glycidyl methacrylate. And we can use acrylic polysiloxane with hydroxyl functionality for 2K polyisocyanate cured durable systems, and one with the acrylic epoxy polysiloxane. Since it has the epoxy functionality, it can be cured with aminosilane actually. So silane is coming from both, basically from the base polymer as well as from the hardener. So it provides tremendous improvement in the durability. Another one is the epoxy acrylate. So this one, we heard in the lecture on the matting agent, matting agent free emulsions. So same thing applies here also. Here if we use the epoxy acrylate for the cured with the carboxyl containing polyester, we can get very low gloss and no use of matting agent. So that is the beauty. And even we can design high gloss system also with this. So both can be designed with the right selection of the monomers. Another one is the waterborne acrylic polyurethane dispersants. So that is prevalent. Basically, a lot of people are already using, and many companies are already manufacturing now in India. And the basic modifier is the IPDI or HMDI, and it finds use in 1K architectural exterior coatings for very good service life actually, and long warranty periods. Fluoroacrylate is another one wherein we can simply modify the acrylic with a little incorporation of fluoromonomer, and it provides outstanding weathering and stain resistance properties for anti-graffiti coatings. Now we come to the polyester hybrids. So in the morning, in the earlier session, we heard about that certain UV curable systems actually with the polyester, but here this is the purely solvent-borne coating, and then the siliconized polyester is one wherein we can modify with the functional siloxanes, and it finds use in 2K PU with exceptional weathering and mechanical properties for top coat for pre-engineered structures and agricultural equipment. And another one is the waterborne polyester urethane. Again, the modifiers are isophorone diisocyanate or hexamethylene diisocyanate, and it is again for high durability and with outstanding resistance to stretching, shrinking, abrasion, and UV light. Acrylated polyester is another resin. Basically, it is not being used so much, but if we modify low-cost polyester with acrylic, we can design good durable system wherein we can use it for 2K PU as well as for 1K stoving system with amino resin crosslinkers. Now we come to the epoxy hybrids. There was a lot of discussion in the pre-lunch session on epoxies, but epoxies are going to stay here. And I saw on Google that it is growing at the rate of 5.4% CAGR every year. So epoxies are not going away in any way. And so first one is that siliconized epoxy. So a lot of companies manufacture siliconized epoxy for high heat resistant coatings. Although the organic binder goes away, but the silicone remains actually on the substrate even at 600 degree for a long period. And another one is epoxy silicone urethane. So again for 1K stoving systems with melamine formaldehyde for high corrosion resistant, and this kind of a system provides very high corrosion resistance performance even at very low DFT. So if we apply coating at 5 micron or 10 micron, it can provide easily 800 hours of ASTM V117 salt spray resistance. Another is the cardinol modified epoxy. So cardinol, as I said earlier, cardinol tremendously improves the corrosion resistance performance because of its functional structure, and no synthesized material can provide the performance like cardinol does. So again, this is used for 2K amine adduct, and basically it is economical also being the natural source, and epoxy resin with very high corrosion resistance performance. So epoxy esters are of course known, and it can be designed in turpentine soluble or xylene or other organic solvent soluble, and it again provides very good corrosion resistance for undercoats and primers with very good drying properties. So these are the basically prevalent technologies, but sky is the limit. Lot of polymers can be designed with these kind of combinations, and we can get amazing properties. Whatever application requirement or specification requirement is there at a low cost, basically. Because when we are modifying low cost resins like L kits to achieve certain performance properties, definitely we can get the low cost, and at the same time we can significantly improve the performance properties. So these are the general characteristics for these resins like color, glass transition temperature, and GPC of course, which decides that how much variation in the molecular weight and then how one resin is different than the other, and viscosity solids, and then the functional properties like hydroxyl value, acid value, or epoxy equivalent weight, amine value, free NCO content, etc. But the most critical aspect for any such hybrid resins, the stability of such resins should not go to the toss actually in the process of modifying. So one has to be very careful and one has to test the accelerated stability. If it is not stable at higher temperature, especially in the Indian conditions wherein the go downs, etc., the temperature may go as high as 60-70 degrees Celsius. So one has to carefully examine all such resins and the products made out of it for accelerated stability. And it should pass at least for 2 months. Now we see that what kind of paint film characteristics we get from these kind of resins, and what do we need to characterize basically when we design such kind of polymers. Then we need to test general properties like drying appearance, gloss at different angles, all those mechanical properties, corrosion resistance, performance, and the chemical resistance properties wherever it is applicable, especially for the 2K systems as well as 1K stoving finishes also, and weathering performance. So accelerated weathering in QUV as well as natural weathering, and other tests like contact angle and thermal resistance, surface energy, word drop resistance. So all those tests are necessary actually when we need to characterize these kind of polymers and coatings based on those. So this is very critical if you look at the seminar theme actually, resins for today and tomorrow. So these are resins for today, and this is going to remain valid for many years in fact, and we need to apply our imagination and thinking, and then we can definitely design number of polymers meeting certain requirements. That's all.
Thank you, sir. Thank you for the presentation. I have one quick question regarding cardinal. So when you say the cardinal is giving really high corrosion resistance, is it like a simply by blending, or is it like a keeping it as a backbone of the epoxy resin?
It should be in the backbone.
Backbone,
it should get reacted.
Okay. So can we achieve similar properties or improve the corrosion by blending it?
Definitely, yeah. Its structure is like that, and then a long alkyl chain, actually C15H27 chain at meta position on the cardinal, that significantly improves actually the corrosion resistance performance, and even because it repels the water basically.
Okay, yeah.
So whether you introduce this in hardener, like a lot of phenylcamines are there, or you introduce this in epoxy resins or in alkyd, so wherever you introduce, there is a dramatic shift in corrosion resistance performance.
Okay. Thank you.
Hello, Raju.
Yeah.
A very good presentation. Actually, it is as per what we were expecting in terms of, what next for all the resin manufacturer present here. So you have abundantly given the possibilities and which are the ideas on which all the resin manufacturers curve one, because people are concentrating mainly on the alkyds and the conventional resins.
Yeah.
With that also they are doing well, and industry's acceptance is also good. But this kind of hybrids and different possibilities can definitely enhance their innovation also, and the innovation towards the paint industry. And thanks for this presentation. Thank you.
Sure. Thank you so much. Yeah.
All right. So with that, we are ending the session over here. I will once again request Dr. Prashant Samant to join us over the stage and propose a token of appreciation to our speaker, Dr. Rajiv Kumar Jain, joining over here from Asian Paints. Come on, everybody. Let's clap loud for Dr. Rajiv Kumar Jain.
Sorry that you feel that way. I'm sorry that you feel that way.
All right, and with that, as we promised, we are all set to welcome over the stage our next speaker, who is going to be a motivational speaker. But before that, we are going to have a small tea break. So everybody go get freshed up and let's get back. And this time we are going to be little more motivated because we are having one motivational speaker right with us, Shanti. And with that, we are moving ahead towards the next session over here. Widely acclaimed and highly honored motivational speaker and leadership trainer with over 35 years of experience, known as the enthusiasm specialist. He has inspired over 70,000 individuals and across 140 organizations worldwide. A former top-ranked Del Carnegie trainer and founder of Polymer Growth Services. Please welcome Mr. Srinivasan, who brings unmatched energy, insight and passion to every stage he steps on. Get ready to be inspired. Ladies and gentlemen, please welcome Mr. Suresh Srinivasan with huge round of applause over the stage. And I will request our co-convener, Mr. S. Madhavan sir, to accompany our speaker, and with that, do propose a beautiful planter.
Hey, all of you are supposed to clap, yeah? जोर से ताली मारो. आ जाओ. Yes, sir. Thank you.
So, Mr. Suresh is going to be with us for a while. We hope you all will enjoy and take maximum motivation you guys can take away. Thank you.
So, for people who don't know me, my name is Suresh Srinivasan. I'm 63 years old. Okay, with 43 years of corporate experience. तो आज मैं ऑफिस रेजिन के बारे में कुछ बात करने वाला है ही नहीं. मैं जिंदगी में मस्त कैसे रहने का इसके बारे में बताएगा. गुड डील, यस और नो? तो एक आदमी था, उसको जबरदस्त प्यास लगा था. अगर पानी नहीं पिएगा तो वो मर जाएगा. एक आदमी उसको पूछता है, तेरे को पानी पिलाएगा, उसके बाद जान से मारेगा. पानी चाहिए नहीं चाहिए? उसने क्या बोला? ओके, गुड इवनिंग, गुड आफ्टरनून एवरीबॉडी. फर्स्ट एंड फॉरमोस्ट आई वुड लाइक टू थैंक. ऐसे करूं क्या? हाँ, तो क्या हुआ? क्या बोला उसने? पानी पिला फिर मार. हाँ है ना? क्यों मैं बोल रहा है? हम लोग सब मरने वाले. एक है रो धो के मर या मस्ती से मर. मरना तो आई विल टीच यू हाउ टू डाई हैप्पीली टुडे. नहीं, गुड ना? यू टू डाई हैप्पीली. मरना तो बिकॉज लाइफ इज अनसर्टन. लाइफ इज ब्लडी अनसर्टन. कभी विकेट जाएगा मालूम नहीं. चाय पीते पीते मेरा जोक याद आएगा. चाय तेरे विंड पाइप में जाएगा, खत्म. अभी कोई चाय पिएगा नहीं, देख तुम. अभी चाय कैंसिल. So all I'm saying is learn to enjoy life, which is what I'll tell you, right? So this guy was enjoying his cup of coffee. पीछे से किसी ने आके उसको जोर से धक्का मारा. कप के अंदर जितना कॉफी था पूरा बाहर आके गिर गया. तो मेरा प्रश्न सिंपल है, कप से कॉफी बाहर क्यों गिरा? गुड आफ्टरनून एवरीबॉडी. क्यों गिरा? धक्का लगा, ग्रेविटी था, उसका ध्यान नहीं था. यही लोग बोलेंगे ना. सबका आंसर गलत है. कप से कॉफी बाहर इसलिए गिरा नहीं क्योंकि कप के अंदर कॉफी था. चाय रहता तो क्या गिरता था? तू इधर बैठ अभी. हाँ, चाय रहता तो क्या गिरता था? चाय. दूध रहता तो क्या गिरता था? तो व्हाट इज इनसाइड द कप ओनली विल कम आउट. एग्रीड? उसी तरह ऑफिस में, तुम्हारा कंपनी में तुम्हारा सबऑर्डिनेट धक्का मारेगा, बॉस धक्का मारेगा, घर में पत्नी धक्का मारेगा, पति धक्का मारेगा, कस्टमर धक्का मारेगा. अंदर जो है वही तो बाहर निकलेगा ना. अंदर जो है वही तो बाहर. तो अंदर कचरा भरा है, तेरी कचरा निकलेगा अंदर से. तो अगर मैं जोक मारूं तू हंसेगा ही नहीं, इसका मतलब अंदर से इतना तू दुखी है कि चेहरे में हंसी आता नहीं है. कोई लोग यहां बैठे टकले, ज्ञान बांटना बहुत आसान है. तू इरमा में आ. कैसे पागल लोग घूमते. So when you have a stomach pain in Ahmedabad, shifting your residence to Bangalore will not solve your problem. Problem अंदर है, solution हम लोग बाहर ढूंढ रहे हैं. उसी तरह तू बोले धंधा बराबर नहीं है, धंधा ये नहीं है. मैं बोला था तेरे को धंधे में आने को? नहीं, मैं बोला था तू खुद आना, चुप बैठ. शादी किया तो निभाना पड़ेगा. हेलो, क्राइंग एंड क्रिपिंग विल नॉट सॉल्व योर प्रॉब्लम. तू सब बोलेगा ये मेरी बीवी अच्छी नहीं है, तू छोड़ के जा, नया वाला ले. फिर बोलेगा पहली वाली अच्छी थी. So solving, learn to, which is what I'll take on a beautiful internal journey. What is inside is what will come out. तो बॉम्बे में देवनार होता है, हाँ ना, देवनार है ना, वहां कचरे के डब्बे में ना गुलाब रहता है ना, तो मधुमक्खी हमेशा गुलाब के पास जाता है. ट्यूलिप गार्डन है हॉलैंड में, वहां कचरा डब्बा रहता है ना, मक्खी हमेशा कचरे डब्बे में जाएगा. जैसे अपने इधर बहुत सारे जन आए कॉन्फ्रेंस में, फीडबैक में बोलेंगे रसमलाई नहीं मिला है, येड़े बैठे इधर. फिर बोले रात को दारू जल्दी बंद कर दिया. अरे बाबा तुम लोग कॉन्फ्रेंस का के बेवड़ा पीने के लिए? नहीं है दुखी है, बहुत है इधर. तो अंदर कचरा रहेगा तो सब जगह कचरा ही दिखेगा. जस तू तस जग, जस तू तस. द आउटर वर्ल्ड इज अ प्रोजेक्शन ऑफ योर इनर वर्ल्ड. तो प्रॉब्लम इधर है, सॉल्यूशन. तो आज मैं तुम लोग को अंदर लेके जाएगा थोड़ा. गुड डील, गुड डील ना. अंदर लेके जाएगा, बताएगा कि तुम लोग ने तुम्हारी जिंदगी कैसा वाट लगा के छोड़े ले, सत्यानाश किए ले तुम लोग. प्रॉब्लम तो रामायण में हनुमान होता है. हनुमान जब छोटा सूरज को खा लिया था, बड़े होते होते उसने भूल गया, जांबवान ने उठाया उसको और वो इंडिया से लंका चला गया. एवरीबॉडी नोज दिस. आप लोग सब हनुमान है, बट किसी का हाँ हनुमान थोड़ा ढीला हो गए, इसीलिए अगले 1 घंटे के लिए मैं बनने वाला है जांबवान. अरे ताली मार सकता है इसके लिए यार तुम लोग? है हमारे में हनुमान है. सो द पॉइंट हियर इज अल्बर्ट आइंस्टाइन हैज गॉट 5 लेवल्स ऑफ इंटेलेक्ट. हाउ मेनी? लाउडली, जोर से बोलो. हाँ, द लोएस्ट लेवल इज, अरे पढ़ो, स्मार्ट बोलो. अबव स्मार्ट इज, above intelligent is brilliant, above brilliant is genius. And you know what is the highest level of intellect according to Albert Einstein is? Simple. हम लोग सिंपल चीज, सब लोग हाथ रखो ऐसे, सब लोग हाथ रखो, सब लोग कम ऑन बोलो. हम लोग बोलो, जोर से बोलो. हम लोग छोटे छोटे चीज की वाट लगाते हैं. अपने ऑफिस में भी कभी कभी होता है, छोटा छोटा चीज के लिए मीटिंग बुलाओ. संडास में पानी नहीं आ रहा है, मीटिंग बुलाओ. मीटिंग, प्लम्बर को बुलाएगा मीटिंग. 80% of our problems in world come because you're not communicating properly. 80% प्रॉब्लम तेरा इसलिए था क्योंकि तू कम्युनिकेट नहीं करता है. खाना बनाती है, पति को देती है, तो रूपल ऐसे से चलने का, सीधा पूछने का खाना कैसा लगा, अच्छा है, बोला थैंक यू, नहीं बोला साले कल से तू बना. प्रॉब्लम सॉल्व, प्रॉब्लम सॉल्व. यस और नो? तो इफ यू ड्रेस अप वेरी वेल, यू एक्सपेक्ट योर हस्बैंड टू टेल योर प्रिटी, टेल हिम कि जब भी मैं अच्छा ड्रेस करूंगी, तू बोलना चाहिए तू क्या लगती है. नहीं बोला चल शॉपिंग जाते. Sir, 80% of your problem in this world is there. Customer is not upset because you're not given the product. He's upset that you didn't even communicate to him, yeah? Oh, बोल ना उसको कि बहुत problem है. They'll accept it. Which is what this is. That's why Confucius said, life is really simple, but we insist on making it complicated. क्योंकि मैं chemical engineering किए ले. मैं पढ़ा लिखा आदमी है, इसीलिए 1+1 के लिए मीटिंग बुलाना पड़ता है. लाइफ इज ब्यूटिफुली सिंपल एंड आई विल प्रूव इट टू यू इन द नेक्स्ट 1 hour कि लाइफ बहुत एक्चुअली बहुत सिंपल है और हमने उसकी वाट लगा के छोड़ दिया है. That is why it is said, skill without will is equal to nil. Skill without अर्जुना को द्रोणाचार्य ने स्किल सिखाया, वो कैसा चलाने का, यस और नो? स्किल तो था, कृष्णा ने उसको एटीट्यूड लेके आया, विल सिखाया. प्लीज रिमेंबर बोथ. तो अर्जुन हैड टू गुरुस. स्किल तुम लोग के पास है, आज मैं तेरे को विल बताएगा, यानी मैं थोड़ा कृष्णा बनने का ट्राई कर रहा है आज. हाँ, इसीलिए बोलता है गांधी जयंती के दिन बेवड़े को अहमदाबाद में दारू मिलता है. नहीं, सो इट इज नॉट अबाउट स्किल, इट्स अबाउट विल. विलिंगनेस है. जिसको धंधा करना है वो धंधा, तो मालिक रास्ता ढूंढ के निकालता है, नौकर हमेशा एक्सक्यूज देता है. मालिक का खुद का पैसा है ना, रास्ता ढूंढेगा. नौकर रहेगा तो मैडम ट्रेनिंग मांगते ना. सो हैप्पी पीपल ऑलवेज परफॉर्म बेटर. एग्रीड? यस और नो? एंड ऑफ द लाइफ अपने को क्या चाहिए? मस्ती से रहो. हाँ है ना? अभी इतना करोड़ रख के क्या खाया आप महादेवन साहब? 2 बटाटा वड़ा, 1 बटाटा वड़ा, 1 बटाटा वड़ा. इसके बाद पैसा ही नहीं है, ये भी 2 बटाटा वड़ा खाया. तो कहने का मतलब है, कहने का मतलब है, the point I'm trying to make it is learn to be happy in life, yaar. So what is the attribute of sugar? Hello, what's the attribute of sugar? Good afternoon everybody. What's the attribute of sugar? It is sweet, yes or no? Yes. So if I eat it also it will be sweet. If an American eats also it will be sweet. Yes. Because the source of sweetness is in the object. Hello everybody, okay not okay? Yes. Whenever it is in the object, it has to be universal. Yes. If it's in the object, it has to be universal. Agreed? Attribute of water is wetness. Wetness, yes or no? Yes. So whether I take bath or an American takes bath, they'll get wet. Yes. Where is the source? Object. The source of wetness is in the object, yes or no? Yes. So if the source of wetness is in the object, it has to be universal, yes or no? Yes. Money is also an object. Hello, yes or no? Yes. So if money is the object, all rich people should be happy. Hello? Yes or no? Are they? No. All Bevdas should be happy. ये शाम के लिए वेट कर रही है. इनका शाम के लिए आया है, प्रोग्राम वोग्राम के लिए नहीं आए. ये फीडबैक में डालेगा रम नहीं था. So where is the source? In the subject or object? No. If money was making you happy, all rich people should be happy. Yes or no? But they are not. Where is it? Subject. It is in the subject. Because there has to be a source. If happy, some people are getting happy, either it has to be in the object or it has to be in the subject. Everybody is clear or not clear? Simple. Now, गर्मी है. You want, it's very cold. Sun है. गर्मी चाहिए तो धनंजय साहब किधर जाओगे? You will go towards the sun or away from the sun? Hey, I want heat. It's cold. Where will I go? I will go towards the sun, because the more I go away from the sun, I'll feel cold. Yes or no? Yes. Interesting. Source of happiness in the subject, and we idiots are running after objects. You see the problem which you created. So you want a qualitative result running after a quantitative thing. Hello? तो जिसके पास ज्यादा है ना, वो हमेशा दुखी है. इसलिए मैं लोगों को बोलता हूं, बहुत सुंदर लड़की से शादी नहीं करने का. रोज बीपी चढ़ेगा, आज भाग गई तो, आज भाग गई तो, आज भाग. इसी समझ गए ना मैं क्या बोला तेरे को? Are you getting the point? Yes or no? So the point here is, I will teach you how to go towards the subject. Good deal? Because if you are happy, whether you have money or no money does not matter. It doesn't, because your objective is to be happy. And interestingly, if you are happy, money will come in the form of Dr. Samant. It will come in the form of Dr. saman, they will come. Now, coming back, this is some international data, okay, on depression. There's a data which is international data. If you are in the higher income come, out of every 1,000 people, 124 people have depression. तो ज्यादा पैसा होने से डिप्रेशन आता है, इसलिए बांटो. No, because no, this is not my data. This is why when you have more. That's why when you have more, you have a problem. That's why it says less is more. They say less is. So the lesser you have, why do men take less time to dress up? Because she's got so many salwar kameez. ये पहनूं, वो पहनूं, ये पहनूं, वो पहनूं, 2 घंटा लगता है. तुम्हारे पास क्या है? 2 चड्डी, 2 बनियान. एक ही है. वही 2 के डालता है. यार. अरे, it is simple to go. So I will. So very clear on the data. So do you want to know how to go towards the subject? Hello, yes or no, yaar? Because if you go towards the subject, you are all the time happy. And what's your goal in life? To be happy. Your goal in life is to be happy. Now your goal in life is to be happy, but you're running after objects. I am not saying don't buy objects. I am only saying remember, तू कितना भी गाड़ी बदल, बीवी तेरा वही रहेगी. वही होने वाला है. तेरा पति वही रहेगा. अभी जो दिमाग खाता है बाद में दिखाएगा, पर दिमाग तो खाएगा. So, you've seen this photograph. By the way, this is some international data about top companies who pay the highest salaries in the world. The list of all top companies in the world who pay the highest salaries. Facebook pays the highest salary to employees. Look at.
Awesome. Can you give a big round of applause to Suresh? And thank you, Suresh, for coming all the way from Bangalore to Vapi on my request. And it was really pleasure to listen to your thoughts, you know. ये वो ऐसा कुछ है ना, वो सब दिमाग में आ गया हमारे. And how to have happiness, everything is now known to all of us. And on behalf of Irma, as a token of appreciation, it is not token of appreciation, it is a good amount, don't have to worry. So we are handing over our convener. Yeah.
तो आज के बाद इसका सुनने का नहीं, किसका सुनने का? इरमा का. जब प्यार होता है, बुद्धि काम
नहीं करता.
फोटो ले लो भाई.
ये फोटो ले लो.
ताली मारो यार तुम लोग सब यार, ऐसे थोड़ी होता है. तो ऐसा हाथ ऐसे बरोबर. बस ये चिल मारने का लाइफ में. चलो, थैंक यू वेरी मच गाइस. गॉड ब्लेस यू. आई विल नॉट wait, I'll leave because I have to catch a train. मस्त करो, रात को ज़्यादा दारू मत पियो.
Yeah, good evening. Can we have everybody on their seats, please? We will be taking just 30 minutes of your time. Can we have everybody seated, please?
Okay,
Suresh, thank you very much.
All right, so that was for you, Mr. Suresh Srinivasan. Everybody, once again, let's put our hands together for the most energetic session that we all have witnessed over here. उम्मीद करते हैं कि सुरेश जी के साथ आप सभी का हनुमान मजबूत हो गया होगा. And with that, we are going to head over closing ceremony of this fantastic day celebration. And आप सभी ने उम्मीद है आज यहाँ से कुछ ना कुछ ज़रूर सीखा होगा. थोड़ी देर में आप सभी के सामने हमारे कोर कमेटी मेंबर स्टेज की ओर आएंगे और क्लोजिंग सेरेमनी की तरफ हम सभी बढ़ चलेंगे. Till then, enjoy yourselves until we make the next announcement. After 5 minutes, we are going to conduct the closing ceremony of this session. So, ladies and gentlemen, please stay with us. And of course, the session was quite enthusiastic and energetic that we cannot stop our energies getting out. But for a while, we have to settle down so that we can proceed with the next session, which is closing ceremony for all. We are moving ahead towards the closing celebration of this fantastic sessions over here, and we would like to invite on stage our core committee members जिनके वजह से ये शानदार से दिन शानदार से सेशंस हो सके। वो दैट आप सभी की जोरदार तालियों के साथ मंच की ओर आमंत्रित करना चाहेंगे हमारे कन्वीनर मिस्टर चलावाला। जोरदार तालियां हो जाएं फॉर मिस्टर चलावाला कमिंग ऑन द स्टेज।
I request to come up on the stage our co-convener, President Mr. and all managing committee members.
So if you learned something, if you enjoyed this day, then please put your hands together for this fantastic team standing over here. And now I will request our convener for the event, Mr. Chalawala, to summarize the seminars and this fantastic days together.
Good evening to every delegates, our all sponsorships, and everybody, and my managing committee. I am happy and glad that the seminar processing and the lectures were good and imparted knowledge to our delegates. The lectures were informative and immense beautiful for all of us. It is my duty to thank all especially our President of Irma, Mr. Hiren Shah, our co-convener, Mr. S. Mahadevan, and our Executive Committee, Mr. Kanan, and all managing committee members for the support you have made to the seminar is a great event in Daman, which was my dream. I take this opportunity to thank all the sponsors, advertisers, and events manager, Devka Beach Resort Management, and the delegates especially. Thanking you, everybody. Thank you.
So that was for us our convener for this event, Mr. Chalawala. And now I may request our co-convener, Mr. S. Mahadevan, sir, for closing remarks.
Good evening. I plan to keep it short and simple in the words of Mr. Suresh Srinivasan. I have added that, I have added my words into Suresh Srinivasan's words. Both of us are Suresh, na? So Suresh with Suresh makes it short and simple. Basically, all of us have assembled here in the last 2 days with one single focus in mind: taking the brand Irma to a height which will be unparalleled in the history of the various associations. As an organization which has been in existence for over, I think more than over 2 decades, it's 3 decades, it's imperative that members do be a part of all the events which the association conducts and ensure that we are able to take this brand to a level which is absolutely, which you call beautiful, on the top. And that's, I think, what all of us are here for. I think all of us for this need a huge round of applause for ourselves and for all of what Irma has been doing for you. I would once again like to welcome you all for the closing. The last 2 days has been historic with our seminar on emerging trends, opening up many doors for an emerging Irma. I call it an emerging Irma because I got a little bit of a feeler from as I was talking to a few individuals across that, yes, why not we take the Irma seminar on a global platform? So that's what I would call an emerging Irma going forward. We had the beautiful butterfly effect, which was given to us beautifully by Mr. Deepak Gaishas, who dwelt upon the 5 disruption which is affecting the global economies and what is its effect on the Indian economy. We started out our day 2 with a Gayatri mantra. I will not be dwelling upon the various lectures, trying to sum up what the speakers say, because it's the speakers who have spoken from their heart, a knowledge which is for all of us to take. It is like you can take the horse to the pond, but you can't make it drink. It's about how much of the knowledge you would like to sink into, how much of it you would like to drink to enhance yourself and improve your businesses across. On behalf of my entire seminar team and the Irma Managing Committee, I would like to extend my heartfelt thanks to all the sponsors who are our backbones, who have made this seminar what it is today. Our platinum, diamond, silver sponsors, the kit, the beautiful kit for the ladies, and would like to thank them once again for their continuous support and patronage for Irma. A huge thanks to the seminar committee, Dr. Prashant Samant, Mr. Manish Khandekar, Dr. Parag Raut, Mr. Bhagyesh Narkade, Mr. Ashay Mehta, our Vice President, Mr. Aditya Chandrachud, Mr. Vikrant Bajaria, Mr. Siddharth Bhai, and our President, Mr. Hiren Shah, and our convener, Mr. Chellawalaji, for their guidance, for their thought processes, and giving you what this seminar is all about. I would also like to thank Mr. Kannan, who is the backbone of the organization. I say backbone of the organization for one simple thing. He's one person, despite his young age. He's been up and about, giving information, reaching out to members, getting information, and even post the seminar, he'll be the one who will be compiling the data, compiling the accounts, sending out the thank you notes to all the speakers across. So that's not a simple job. Requires a lot of, minute details, look into the minute details, attention, and all those things. I would like to thank our hospitality partner, the resort, Devka Beach Resort, Mr. Bhaskar, I hope he's here. Our event partner, Princey Sound Systems, Mr. Keyur, for their effective handling of the entire processes. Last but not the least, an event of this magnitude could not have been effectively executed without the support of the entire team and all you members and delegates who are basically the heart and soul of the organization. A big round of thanks to all and each one of you. As a token of appreciation and as a gratitude towards all the sponsors, I would be calling out the name of all the sponsors or any of their representatives. We request them to please come forward, come on the dais to accept their mementos. I would request our convener, Mr. Chellawalaji, along with our president, Mr. Hiren Shah, to please do the honors. The entire team can also be a part of this, a noble cause of honoring our sponsors. Can I have somebody from Aditya Birla, Grasim Industries Limited, our title sponsors? Is there anybody over here? Nobody's there. Mr. Gajanan Joshi, he was here somewhere. From Uniform Synthetics Private Limited. We can have Dr. Jaiswal over here. Dr. Raju. Can we have a huge round of applause? I think the applause can continue all across. We've had a hearty lunch. We've had, I think everybody has eaten at least minimum 2 or 3 batata vadas, as Mr. Suresh Srinivasan kept on asking. And still, I think we will wind it up very fast because there's still a long, long way to go before the bar opens. And we have kept to our promise of closing the event on time, which I think I would like to thank the entire committee for getting it done for us. Good, we have from Allnex Industries, our platinum partners. Anybody from Allnex Industries? तालियां रुकनी नहीं चाहिए. Am I being covered? Tipco Engineering India Private Limited. Talia, please. See, the more you clap, the more will they be, what do you call, वो बोलते हैं ना, प्रोत्साहित होते हैं अगले साल आपके साथ वापस जुड़ने के लिए. हिरेन, एक जन from the committee से करा के, from the committee से एक सबसे करा के लिए ना. Our diamond sponsors, starting with Asian Paints Limited. Fairchem Organics Limited. Anybody from Fairchem Organics Limited? Fine Organics Limited. Fairchem Organics and then Fine Organics. They're two different? They're two separate. Fairchem Organics Limited. Fine Organochem Private Limited. Sorry, correction, Fine Orgochem Private Limited. Gargi Hutons Albertus Private Limited. Naik Sab has, I think, committed for platinum next year. Huh? Himalaya Terpenes Private Limited. IG Petrochemicals Limited. तालियां रुकनी नहीं चाहिए प्लीज. KLJ Resources Limited. KLJ Resources Limited. Anybody from KLJ? Mehta Petro Refineries Limited. Anyone from Mrs. Aditya Birla group over here? I think they require a huge round of applause being our title sponsors for this event. They were the first one. I know that going out of
Hey, Dr. Gajanan, can you come forward?
Pidilite Industries Limited. Any representative from Pidilite Industries Limited? Yes. Prakash Chemicals Private Limited. तालियां रुकनी नहीं चाहिए प्लीज. गिर जाएगा.
संभालने के लिए रखा हुआ.
Thank you very much. रेडा केमिकल्स इंडिया प्राइवेट लिमिटेड. नहीं 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 इसको नहीं, और कोई और ये नहीं ये Kansai Nerolac Paint Limited. Tridev Resins India Private Limited. कौन लिखा है? कुछ इसको पूरा नहीं गला. हाँ कुछ इसको पूरा. उसने ऐसा नहीं करना. ट्रॉफी बनाया है उसका. मेरा ही उसको फोटो के लिए दे दी. इसका पार्टिसिपेंट आपका हाँ वही मैं पूछा वो कंफ्यूज हो गया था क्या है ग्रुप में आदित्य ने ओके मुझे वाटर है नहीं तो यूज से ऐड किया और सेमिनार वो बना ले बना ले फिर वही कंफ्यूजन नहीं होना मिलता है. यस यस. Sir, thank you very, very much once again. Vimal Intertrade Private Limited. Our silver sponsor, Mrs. Anupam Colors Private Limited. Anybody from Anupam Colors Private Limited? Our cosmetic kit sponsor, Mrs. Borokris. Anybody from Borokris? Other than Aditya, we don't want Aditya. ये Borokris में that is acceptable. I would now love to thank and honor our seminar committee who is standing in front of you. The efforts the efforts of whom has been visible for the last 2 days. Can we have the mementos, please, for Mr. Aditya Chandrachud, Mr. Bhagyesh Narkade? Can we have the mementos fast, please? Then just check your names and take the memento. Aditya Chandrachud, Mr. Bhagyesh Narkade, Dr. Prashant Samant, Mr. Ashay Mehta. The convener and the president do the honors. Dr. Parag Raut, Mr. Gaurav Satya, Mr. Manish Khandekar, Mr. Vikrant Bajaria, Mr. Sanjay Randive and Mr. Raj Narkhede. We don't have Mr. Sanjay Randive. A huge round of applause for Mr. N. Kannan, who's, as I said, has been the backbone and who does deserve an applause. I think which, इसमें कंजूसी please मत कीजिए आप. चलो, I will thank you once again to everyone from the bottom of my heart. I now hand over the stage to our president, Mr. Hiren Shah, for his final conclusion of the event.
Namaste once again. Friends, as we draw the curtains on what has been an enriching and inspiring two-day seminar, it gives me immense pleasure, a deep sense of pride to deliver this closing address. Over the past 2 days, we have dwelled into many dimensions of resin industry. Our speakers, leaders, researchers, entrepreneurs have generously shared their insights, sparking conversations that will surely guide our collective efforts in the years ahead to come. The emergence of bio-based resins, circular economy models, and green chemistry are not just trends. They are imperatives, and our association is committed to leading this change responsibly. Thanks to the entire seminar committee, industry partners, and sponsors for your support. That has been the vital to the success of this seminar. Moreover, thanks to all the delegates for your enthusiastic engagements. It is in your presence and participation that turns events like this into true platform for change. Thank you everyone in this hall. Last but not the least, like Suresh Srinivasan said, अगर किसी को रसमलाई नहीं मिला, गुलाब जामुन बुरा लगा, या बार जल्दी बंद कर दिया, तो रोने का नहीं. जोक्स अपार्ट, आपको कुछ कमी लगी तो फ्रॉम मी एंड माय एंटायर सेमिनार कमिटी मिच्छामि दुक्कडम. Friends, have a safe travel tomorrow. Let's stay connected. We will surely meet soon. Thank you. Moreover, I would like to give a token of appreciation to our co-convener, Mr. S. Mahadevan. A token of appreciation to the man behind choosing this venue, Mr. Challawalaji.
Two names that we forgot in our Thanksgiving is our beautiful hostess Urmika and the ladies out here, Manashwi, and I couldn't get the other lady's name. Aapka naam? I didn't. Round of applause for them. Seema. I think they do deserve a huge round of applause for all that they have done for us. And one last small thing to our great president, Mr. Hiren Shah, a token of love from the entire committee. I request Chelawala ji for one last time to please do the honors. Hospitality partner from Devka Beach Resort, Mr. Bhaskar. Mr. Keyur from Princey Communications. Can we have both of them over here? Keyur hai? He's the one who's done all these things at a good price.
Friends, someone wants to give a feedback? It's an open mic.
Guys, just a minute, please, just a minute. Actually, I really want to congratulate this young team where you have 90% of the people who are really young. This is for the first time I am seeing this team because I have been associated with Irma as many years, like 30, 35 years, like how my father is there, I was just behind him. I had an opportunity to be a committee member, but I did not. And this second generation has really taken over, and I really, with heartiest congratulations and all the best to you guys.
You're most welcome.
No, thank you. I'm an outside only, I'm good. And thank you, Irma, for giving us the award to my father. Thank you.
We officially declare the seminar as complete.